Okay, good morning, everybody, and this is Dr. Mansour, and today is May the 22nd. Thank you very much for coming today. This is the FE Civil Review, and if you look to the schedule that I updated the schedule, and I added more. Today is the 22nd. Saturday, May the 22nd. In the morning, we are going to cover the surveying chapter, which is chapter 9, bare NCEES numbering system. And this afternoon, I'm going to cover from 1 to 4:30 the transportation chapter 13. I finished it, okay, this morning. In fact, I need to add just 2 more problems if I can. If not, I will send it to you. It does have 38 problems already. So, and it does have a lot of topics to be covered. So I will do my best during the lunch break is to add these 2 problems. If not, I will add it later on. I will discuss it. So this is the schedule for today. We are going to have another meeting this coming Saturday. Also 1 full day from 8:30 until 4:30. And the last day will be for this free review will be on the 5th of June, June 5th. So this is what the schedule as we see right now. Hopefully that the book will be ready this summer. I'm doing all my best. I hired a new engineer. He just graduated from CSU Fresno here, a mechanical engineer. He helped me with a lot of things. So you will see that on our website, if you go to PESE.com, he already did. He put all the recordings, by the way, for you to watch it again on demand. So if you click on that, it will take to YouTube. In fact, we put them at 2 locations, YouTube, and we'll put it also on the company that I'm using for this webinar. So if you click on one of these, you will be able to watch the videos again, as many as you want for free. And we'll keep adding. For example, today's lectures will be loaded on the system also, and using the same link. So basically, you'll go to our home page, and you will find that this link to view or to watch the FE Civil recordings. And I believe this is a new brochure. I believe this is a current one, the one I'm using. It does based on this is a current one. So I'm trying to do my best to update everything, and we will do our best. On Amazon, I was trying to locate my books. I have about 18 books. Some of them, they need to be updated. The material I'm going to prepare, by the way, or I'm providing to you, for example, surveying. I have about 4 or 5 surveying books. This is the textbook, okay? The surveying for California. So the chapter that you already received it from me, it's based on this book. So which is, this is the older edition, by the way. This is the first edition. Now I have a second edition, but we didn't put it on Amazon yet, okay? I don't have time to put it, but probably the new engineer, maybe he will be able to find some time to put the second edition, and surveying, seismic, the 5th edition, transportation, the 3rd edition, and so on. So let's start. So I started last time, and I will start the chapter from the beginning, the surveying chapter, and I will do my best. Bear with me. I know there's a lot of material. This chapter 9. All of you received this, and during the lunch break, as I said, I will do my best to add these 2 additional problems, or 2 problems I would like to add into the transportation chapter, and I hope I can do it. If not, I will send it to you during the lunch break. Please print it, and we will go over the transportation this afternoon. So surveying is chapter 9, bare NCEES CBT exam specifications. Here are the topics that listed by the NCEES. So I took these topics and I covered them using my surveying textbooks, in addition to all the surveying references I have in my record here, or my library here. So we covered this last time, so I will go over what I covered last time very quick, just to um, remind you. The definition of surveying, basically we are locating points horizontally and vertically. So there are two definitions I added here. This figure here, which is figure 9.1, shows the types of distances, the horizontal distance and slope distances. We'll talk about angles, horizontal and vertical angles. We're talking about elevations, vertical distance, or differential distance. So this is figure 9-2 is talking about differential leveling, where we have an instrument level and we have the surveying rod, and we take two shots and we can determine the difference in elevation between points, or determine the elevation of points if we need to do that. The following figure, figure 9-3, this figure shows the difference between horizontal and vertical angles. And the vertical angles, as you know, that it could be positive, it could be negative, and we are going to see a section talking about that when we talk about. So horizontal and vertical angles, I need you to know the difference between them. A horizontal angle, it must be in a horizontal plane, and vertical angles like V1 and V2 are located in vertical planes. I added the types of surveying just for your knowledge, because in January 1982, PLS, the professional land surveyors, they were a little bit unhappy that the PE, they are doing the same work as the PLS, so they changed the law in January 1st, 1982, in fact, January 1st, 1982, where they limit the PE to do certain types of surveying. And the PLS, obviously the professional land surveyors, they can do all kinds of surveying. But any PE who is registered before January 1st, 1982, he legally is entitled to do all kinds of surveying as PLS, but he cannot claim the PLS title because he did not take the examination and the process of getting the PLS license. So, for example, control surveys is limited only to PLS. We cannot do it right now, okay? Topographic surveys, yes, okay, we can do it. And land, boundary, and cadastral surveying, no. Hydraulic surveying, yes. And I cover this in depth, but I needed to know types of surveying in general. I don't expect that they will ask you about who is entitled legally or who legally can perform, because this is not listed among the NCEE's topics. As-built surveys, which sometimes we call it final surveys. Final surveys after we finish the job with all CCOs and all the change orders. We can, or we are required, in fact, to establish the elevations and distances and everything for the job after it's completely done. We call it as-built surveys. So when an engineer comes after us, he will see what has been accomplished in the previous job. Mine surveys, solar and condominium surveys. Surveying in general can be classified to be the plane and geodetic surveys. Okay, plane survey and geodetic survey. Geodetic survey, obviously, it takes into consideration the curvature of the earth. But this one, we are assuming that the earth is flat, and this is reasonable or good enough, or reasonably enough or accurate enough for small areas and short lines. But here we use this for establishing the control surveys. Leveling equipment, we are going to see the level and the leveling rod. Figure 9-5, talking about horizontal distance, vertical and zenith angles. All these things are identified here. Also, surveying can be classified as ground surveys, aerial surveys, and satellite surveys, and explain the difference between all these types of surveys for your knowledge. And the section that given in the NCEES, they are asking you to be familiar with angles, type of angles, distances, types of distances, and trigonometry. And this is the first key thing that you might see on the exam as far as problems. So angles, I talked about different types of angles: interior angles, exterior angles, and deflection angles. Okay, deflection angles are really, really important, and we're going to see it today also in the afternoon when we will talk about the horizontal alignment or horizontal curves. This figure here, which is figure 9-7, it shows the types of deflection angles, either deflection angle to the right or deflection angle to the left, which is basically deflection angle is formed by extending one line with respect to another, and they agreed that the right deflection angles were assigned a positive and left deflection angles were assigned negative signs. So I mentioned all these things. The sum of the deflection angles, I needed to know that they add up to 360. So the deflection angles for any closed polygon, okay, they should add up to 360, taking into consideration the positive and the negative. The positive associated with the right deflection angles and the negative sign associated with the left deflection angles, and this is the first. This figure here shows different types of angles like station angle, okay, experiment angle, and deflection angle to the left. Here it is. This is to the left, and this deflection angle to the right, as I explained last time. Another two equations they are expecting you to know for internal and external or exterior angles. The sum of the interior angles for any closed polygon of a closed polygon is n minus 2 times 180, when n representing the number of sides. And for the exterior angles, basically it is n plus. So the difference between this is negative and this is a plus. And if I remember correctly, in the first homework I sent to you, there was a problem related to this, and I hope that you get a chance to work homework number 1. I will try to find some time, like office hours or so, to squeeze some hours to go over homework number 1, and probably I will give you more homework, okay, related to the topics that covered after that. So these two equations I need you to be familiar with. We went over this problem very easily, okay, last time, 9-1. This table here shows the summary of the horizontal angles. Probably if I change the title, and please add this, types of, I will make sure that you are really aware that we are talking about horizontal angles. So probably it will be a good idea to add that types of horizontal angles to make sure that we are really talking about. Okay, so the deflection angles, we said they add up to 360. The n minus 2 for the interior angles, and for the exterior angles, the n plus 2. So this is a plus and this is minus. And here we're talking about horizontal angles, and probably I will modify this table, okay, to add the word horizontal here to indicate that we are talking about horizontal angles, not vertical angles, okay, because very important to distinguish between horizontal and vertical angles. So if you flip the page, you will find the definition of two types of angles, vertical and zenith angles, since we're talking about two. So I define each one of them. Vertical angles are really important. For the sake of the exam, I don't expect that he will ask you about something related to zenith angle, maybe, but here is a definition just in case. And I needed to be aware that the vertical angles, we have the plus and the minus, and again, this is a plus if it is above the horizon, and this is a minus is if it is below the horizon, and I needed to be aware of that. So the horizontal line, any vertical angle above the horizon or above the horizontal is considered positive. Any vertical angle below the horizon is considered negative, okay? In fact, in the survey class that I'm teaching, I have about 497 problems, and even the book itself, it's titled like that. If you need more problems, I do have a book. It's called 497 Surveying Practice Problems and Solutions for the California PE. It is CPT exam also, like, so a lot of problems in this book talking about the deflection angles, vertical angles, and zenith. But this is a special exam for the California PE. And there is one problem specifically, I will be glad to send it to you, just the vertical angle here, plus and minus. Okay, this problem is a very good problem. In fact, does have the law of sines and law of cosines, plus all the terms related to. I will be glad to send it, or maybe I include it as part of the homework. But for the time being, let's focus on what's here, because I need to be very concise to the NCEES topics only, without really going beyond that. Bearings, we talked about bearings. A bearing of a line is basically the bearing of a line is its direction within a quadrant. We have 4 quadrants, as you know, and for bearings we need the north direction or the south direction, and the angle in between, like this: southwest, northwest, northeast, northwest, and so on. So basically, you look to the north direction, and this is the south, and this is the east, and this is the west. So the line could be here or here or here or here. So it is northeast and northwest, okay, southeast and southwest. But we need an angle, okay, degrees, minutes, seconds. And as I mentioned last time, please do your best, whatever calculator you are using. This is the calculator that most of the engineers are using for the FE 7. It is FX115ES Casio plus, and they have different, okay, new models, in fact, but most of them, they are working the same way. Try to do your best to, if you are using HB or you are using TI or using other calculators, please do your best to make sure that you know how to convert degrees, minutes, seconds, because it's very important. Bearing calculations, I do have a problem 9-2. And this is a problem that I was talking about last time, and I said that these internal angles are given, and make sure that they add up to n minus 2 times 180, unless they mention in the problem statement that this is a balanced traverse. Okay, this is a closed traverse. What is a traverse? A traverse, basically a polygon, consists of series of lines, and we are going to talk about adjusting traverses, because sometimes the traverses are not adjusted and we need to adjust them to close them. So basically you need to make sure that the internal angles must add up to the proper addition, or the n minus 2 times 180. And basically this line is given, the bearing of this line, this is northeast, so this is given. And if there is no any adjustment for the angles here, so in this case we are assuming that all the angles are correct, and after that we'll proceed by the calculation. This is the north east, which is a given bearing for line AB. For line BC, you draw, and here is the angle 127.11. So in this case we can determine the bearing of this line, and always draw a sketch, please, a sketch or a free body diagram, or the term that I'm using to translate into English. Azimuth is, okay, or azimuth. Azimuth is basically is also the azimuth of a line is its direction as given by the angle, okay, between a meridian and the line, and measured only clockwise only. So the azimuth is measured clockwise only, and normally you measured from north. Okay, and the azimuth could be, by the way, true grid or magnetic, like bearings. Bearing also, a bearing of a line could be a true bearing or a grid bearing and a magnetic bearing, and I'll be glad to talk about the difference between these later on. So basically you are rotating the angle clockwise, measured from north, and I give you some examples here. We need to know also what is known as a forward and back azimuth, and forward and back bearings. So a line CD, when we say that the bearing or the azimuth of the line CD, this is the angle CD, but DC, so in this case you are going to add the 180 to it. So you are going to add 180, okay, to this angle, which is basically this what. So we have something called forward. So the bearing of line AB, okay, AB, for example, okay, and if this is north, this is the angle alpha, okay. So we say that the bearing of the line AB is basically is north, angle alpha, east. But if they ask you what is the bearing of the line BA, this is, you are going to set your coordinate here. So it became southwest in this case, southwest. So instead of northeast, this is for AB. But for the BA, which is a back, okay, in this case is going to be south. Angle alpha, because this angle alpha is the same angle alpha, by the way, opposite, so, but it's southwest in this case. So be careful with this, because this is a common mistake. I provided a table also, and my all books, the 15 books I have, always I try to make it as simple as I can and concise as much as I can, and tabulated values or tables in general. I found it's a very effective way, and engineers, they like that. So this is the table that shows the difference between bearings and azimuths. So bearings, they vary from 0 to 90. This is 0 to 360. Here require two letters and numerical value, like northeast, southeast, southwest, northeast, northwest, and so on. Okay, so you need two letters and a numerical value in between. Okay, so they might be expressed as a true or magnetic or a grid, or even sometimes assume, by the way. Sometimes we assume a bearing forward and back also, or forward and back. They measure the clockwise and counterclockwise. So this is clockwise, and this is, it could be also measured counterclockwise. It depends on the quadrant, because here it is. We have, this is north, and this is south, and this is east, and this is west. So this is a quadrant number 1, and this is a quadrant number 2, quadrant number 3, and finally quadrant number 4. So it depends on the location. But for the azimuths, okay, azimuth of a line, it is measured from north and measured clockwise only, so from north. Very rarely you will find that the azimuth is expressed from south, but they agreed from north and clockwise only. But for the sake of the exam, he give you azimuth measured from south. Take it. I will take whatever. Very rare, to the best of my knowledge. Very few books they talk about the azimuth measured from south, but this is very rare, as I said. So we need to know the difference between, and how to convert it from one to another. How I convert it from bearing to azimuth, or from azimuth to bearing. We can do that easily, since we know how we. Okay, distances are important, and we need to know how to calculate the parameter, how to calculate distances between points, because they are expecting that you will be able to do that. I started here with a circumference of a circle. All of us we know. So if you have a circle where the diameter is d, or the radius, we are using sometimes radius, we are using d. Okay, so it is 2 pi r or pi d. The length of an arc is proportional to the central angle. So if you do have an arc and the corresponding angle alpha, please draw this picture. Probably in the future I will add this. This is the length of this arc. Okay, and this is the radius r for a circle, for the circle where the arc is taken. So this is arc. Okay, here it is, an arc. So it's basically proportion alpha over 360, and this is degrees, as L over 2 pi r. This relationship is important. Few problems. 93. We need to get the parameter of this. So parameter means you are going around the, okay, you are walking or running. If you have a track like this, you are. So basically, you are adding all these things, and this is very easy how to find the parameter. Okay, the parameter, here it is, and check my calculations, and also look to the 4 possible answers. Sometimes I change the order. For example, this is 50.72, the answer D. So if you find a typo or a mistake, let me know, and for sure the final copy, if for sure it will be reviewed more than once by me or by also some of my assistants. Problem 9.4 is asking for the parameter of this figure 2. So basically I need this, and I need what is on the remaining portion of this circle. So this is what is meant by the parameter. So I will go around this. So basically I need this here, and I need this here, and I need the entire parameter, but I will subtract this. There are more than one way to do it, by the way. This is the way I did it. I said, okay, I have 10 and 10, because this is the radius is 10, and this is 10, plus this is 60. So what is left here is what? Is 360 minus 60, which is 300. So 300 degrees. That's why I use the 300 degrees, which is the difference between the entire circle angle, which is 360. So I proportion the 300 with respect to 360 and multiplied by 2 pi r. Because if it is if the circle is complete. Okay, but we are missing portion of it. This portion is missed. Okay, so in this case, we proportion the central angle, okay, with the entire circle angle with 360, okay? And again, 72.36, 72.36, this is the answer B. So far, so good, okay? If you look to the trig, there are two important laws, and these are given, by the way, in the math section. And I hope that all of you have the NCEES, which I mentioned more than once, the NCEES 10.0, which is available. You can download it or you can purchase it from the NCEES So please try to do your best to get this, because I will refer to it a lot. Okay, every time I need to show you where are these equations, where they are located in the book, because this is the only book, as I mentioned before, you will be seeing on the exam. So the law of sines and the law of cosines. So very important two laws. And here is the problem. And I believe I took this problem from the NCEES, if I'm not mistaken. So basically, if you'd like to draw a picture, by the way, for this, let me draw a picture. So A over sine A, if this is the dimension A and this dimension B and dimension C, this angle here, we'll call it angle A. No, let me call it this A, since I'm okay. And this is the angle C. And these are the interior angles, by the way. And this is the interior angle B as in boy. Uppercase, let's make it uppercase, and this is uppercase, and these are lowercase. So the dimension A of this triangle, this side here, divided by the sine of the opposite angle as the dimension B, and so on. So the law of cosines, it is A square is equal B square plus C square minus 2B times C times the cosine of the angle in between. And these two laws are very, very important. I need you to remember them, and a diagram like this. And sometimes, by the way, instead of searching in the NCEES, you should remember some equations, and by practice, you will be able to remember some equations. I'm not asking you to memorize every single equation, but instead of searching in the PDF of this book, okay, and probably this will take time, some equations I need you to do your best to remember them, and by practice, I'm sure that you will be able to locate, remember them. And if you have suspicion about one of these equations, and so in this case, you can go to the section of the NCEES reference book and locate it. Okay, for example, this is what I'm looking for. Here it is. This is the on page 37. Okay, so the trig, here it is. So this is the definition of sine and cosine and tan. And here are the two laws I'm talking about. This is on page 37 of the NCEES book. NCEES book, okay? So I'm using the same notation they are using. This is A, B, C, and here are the two laws I just talked about them, okay? So the problem in front of us here, you have a triangle over three sides, 1, 2, 3, and it's asking what is the angle A. So in this case, immediately I will recognize that this, the law of cosines, where we are saying that A square is equal B square plus C square minus 2, B times C times cosine the angle A in this case. So the cosine of the angle A, this is unknown, this is the only unknown. So in this case, we'll solve it, and here it is. And again, be careful, because the angle, it will be expressed to you, will be given to you. So if you do this math, okay, you will not get this, okay? You'll get an angle in degrees, and after that, you are going to convert it to degrees, minutes, seconds, because as indicated here, degrees, minutes, seconds, and we need to know how to do that. I will add this number next time. That just do the simple math, and but the angle here will be in degrees, and after that we convert it degrees, minutes, seconds, because the answers are given in degrees, minutes, seconds. Okay, make sense? Easy stuff. Can you do this? Because you have, as I told you, you have 5.5 hours, and you have 110 questions. So we have to be fast and accurate, or we have to do our best. Okay. If you look to the second section of the NCSS, which is the area competitions. Okay, area competitions, these equations here are given in the 7th section, and I showed you last time, and I highly recommend you to write the page number, okay, of the sections I'm providing. At least you can locate them easily while you are reviewing, and you will memorize them by heart. You promise me that you are going to study very hard and memorize them by heart. So if you look to the area, this is given on page 307. Page 307. 307, here it is. I will write, I put here on the side, probably in the future, maybe, okay, probably I say the NCFE reference handbook. Do you know what? I will say page number here. It will be very good idea, page 307. This is a modification I will add. I will add the page number here, page 307. And again, this is the 10.0. So page 307. But for the time being, put the page number, at least you can go to the original equations in the original book to see it. Okay, maybe I have a typo. I did all my best to go over all the equations. But if there is a typo, please let me know, and I will take care of it. Okay, and I'm doing all my best. So probably I will be add the page number here in the future. So area formulas. We have this area by coordinates, trapezoidal rule, and Simpson's 1/3 rule. Those are the three methods that discussed by NCSS. There are some other methods, by the way, but those are the three methods that given in the NCSS. So the reason that we need to calculate the area, because the area will be used to calculate the volume of earthwork. We need an area, and we're going to see three methods: the average and the area method, the Prismodial formula, and the prism or the pyramid or the 1/3 rule. I did my best by providing a little bit of theory about what I'm talking about. For example, methods of measuring areas. Can we measure an area? Yes, it could be measured or it could be calculated. Field measurements, if you go to the field, and obviously this will be more accurate if you have a piece of land, and I'm asking you, what is this area here? Okay, the parcel I bought, and I need you to verify it for me to see if the area that I got is the right area. So basically you are measure the dimensions, and after that, this here you can divide this into small figures, or regular figures, or simple figures, rectangle, triangle, trapezoid. You can use offset from a straight line. You can use coordinates. Coordinates is here, by the way. Coordinates, area by coordinates. It also does have the name crisscross. Crisscross. So if you see this term, and here it is, crisscross. So probably I will say that. And this is a very powerful method, and we're going to see it. The equation a little bit, I don't like to say confusing, but I presented a little bit different, and we will talk about this. Okay, but if you'd like to use the equation as given here, that's fine. I will show you, okay, how you solve or calculate the area using coordinates. And I believe the problem I solve it both ways, if I'm not mistaken. Okay. Also, area can be computed or calculated from maps, if I have maps. Okay, and sometimes we use maps. Obviously, the accuracy depends on the quality of the surveying that used to produce the maps, map scale, and the precision. There is one method here, by the way, before I leave the field. It's called DMD. We don't cover this. It's called double meridian distance. I cover this in depth for the surveying, but it's a very complicated method and lengthy one, and nobody will ask you. So I need you to be aware of that. Okay. From a straight line, the offset, we are going to see the trapezoidal and the Simpson's rule, which is basically the offsets from a straight line. We need to remember maps also could be used. I doubt that he will give you a map to compute the area from a map. We can count the coordinates, squares, divide the area into smaller shapes and calculate the area, digitize it, which is, we use it a lot nowadays. And there is an old instrument. It's called the planimeter or a planimeter. Okay, I do have one here. I'll show it to you. Planimeter is an instrument. It was invented if you do have a lake and you need to find the area of this lake on a map. It must be, you must have a map scale. So we rotate clockwise only, and we take the area. We go around the perimeter, and after that we use the number that we are getting from the planimeter to calculate the area of a lake or a parcel or anything, using the map scale and so on. I believe I have a problem also. We need to remember the area of a circle. Okay, the area of a circle is, if this is a diameter d, and this is the radius r, so it is by d squared over 4 or by r squared. We need to remember the area of a trapezoid, or this simple stuff. If this is A and this is B and this is H, so obviously it is A plus B divided by 2 times H. This is the area of a trapezoid and this is the area of a circle. And I'm sure that you remember all these things. But to remind you, here's some applications. 9.6. I have two figures. What is the area of figure 1? So the shaded area, this is what probably the shaded area, at least it will be much more precise. Obviously, this is what is meant. So basically, you can take the entire area and subtract a quarter circle and subtract the circle. And this is what I did here. So you can say that this is 5 and this is 7. So 5 by 7 will give you the area of this rectangle. And you subtract a quarter circle, which is a pi r squared divided, okay, by 4, which is a quarter. And after that, we subtract the area of the inside circle. So this is one way. Okay, there are some engineers do it differently, or you may do it differently, but normally I encourage everybody to ask. If you solve a problem, ask yourself this famous question that I raised it last time, or maybe raised it many times before. Is there any other method, okay, or method or way, a shortcut, if you like to call it shortcut? I have no problem with that, because we need to save time. So if you solve the problem and ask yourself, is there any other way to do it? It's much easier way, less computation, or fewer steps. So please try to ask yourself this question, because time is the biggest enemy for you during the exam. Problem 9.7, I took the figure 2, and also the shaded area. Probably the word shaded area is something to indicate that we are interested in the shaded area. So in this case, again, more than one way to do it. I took 9 times 6, which is the rectangle. And after that, I subtract this, a quarter circle, and I subtract this square here, which is 3 times 3. Okay, this is, so basically you took the entire area and subtract this, and you subtract this. Make sense? Okay. Sometimes not necessarily a figure will be given to you. Sometimes they can spell it out like this, like a problem 9.8. A ditch with a trapezoidal cross section, okay, where the top width is 28 feet and the bottom width is 4 feet, and the depth is 6 feet. So basically, this is a trapezoidal shape, the irrigation channel or a ditch. Okay, something like this. So it's asking what is the cross-sectional area. This is an easy one, that this plus this divided by 2 times h, and here it is. And units, by the way, be careful. Sometimes they can ask you this area to be, okay, inch square, yard square, name it. Okay, so and we need to be familiar with the SI units. I believe the exam is given also in SI, if I'm not mistaken. I don't know if they mentioned this at the beginning or not. I believe the SI units, the System International, also could be included. They have tables at the beginning to convert. Yeah, the units. Okay, at the beginning of the book, by the way, units units and conversion factors. This is the NCEES. I needed to be familiar with this because we have the acres and square feet. How many square foot? Okay, per 1 acre, the 43,560, this famous number, and also they have it also in metric. So we need to be familiar with the metric also. So what else? Yeah. And they have the significant figures also on the brief. This is page 1, by the way. Units and conversion factors. This is on page 1 of the book. I need you to be familiar with this. Sometimes they say mega, giga, tera, and so on. The gallon of water, if you remember when we talked about the water cement ratio, the 8.34 pounds. Okay, 1 cubic foot of water is 62.4 pounds, and so on. Mercury, and we need to be, and also the Fahrenheit and Celsius, and so on. So all these things are important, and please do your best to locate them in your copy and get familiar with some calculators, or not some. Most of the calculators nowadays, they have the conversions and you can convert it easily. But try to do your best to. But pay attention to this. Sometimes they put the units here, sometimes they put it here, by the way. Feet square or square foot here, square foot, square foot, square foot, okay? Sometimes they give you the dimensions here in inches, okay, in inches. And I do have some problems related to this. Okay, I do have a question here. What is the side slope, horizontal to vertical, of this ditch? We're going to see side slopes today, by the way. Side slope, slope, let me just mention this because the term slope is important. Slope, there are two terms I needed to be aware of: the side slopes or side slope and the cross slope. Okay. And the term grade, we are using letter G, by the way. For it, a grade, it could be a positive grade and a negative grade. And we're going to see one equation this afternoon. It's called the stopping side distance, SSD. If you remember the SSD last time, we talked about SSD. SSD, it could be a stopping side distance. Stopping side distance, the one we're going to see this afternoon, side distance. And the one we covered last time, do you remember? Saturated and surface dry. Saturated and surface dry. This is for the aggregates, for the coarse aggregate and the fine aggregate. After we do the calculations, we need to make sure that we adjust the fine and the coarse to the SSD condition, saturated surface dry condition. And I hope that I believe I scanned and sent you my notes. If you did not receive my notes, I have all my notes, by the way, located in one folder, and I did that a few days ago. I would be glad to send all of them one time. So all my hand notes are available, and I need you to write after me. Number one, not to, so number one, because I need you to pay attention and you catch my mistakes. And also, I don't like to think about the stock market. I need to think only about what we are covering here. So while you are writing after me, your knowledge will be increased and you will be absorbing the material at a higher rate or at higher efficiency, as we call it. So side slopes and cross slopes. When we're building freeways, as we're going to see in the volume computations, or highways or streets or any earthwork we do, this is a fill or embankment. So we build, okay, at a side slope. This is horizontal and this is vertical. This side slope nowadays, minimum we are looking for 4:1. 4 horizontal, 1 vertical. It used to be 2:1, but they changed the code. And this is the center line. And we're going to see something this afternoon is called PG, a profile grade. So this, we'll call it side slope. Side slope. And the side slope is 4:1, as I told you, is a minimum. We prefer to be flatter, by the way, in order for to prevent erosion or disturbing of this soil here, and also for safety of the public, because the crash will be less severe if we make this slope as flat as we can. But obviously we are limited to the right of way, and this point, by the way, is called catch point, CP, catch point. And this point, by the way, we call it HP, hinge point and catch point. Okay. So this is what is meant by side slope, side slope. This is a side slope. A cross slope, when we take a cross section of this road, we draw it that way. This is the center line, and we have lanes, whatever the number of lanes. Okay. And lanes, they have certain slope, and shoulders, they have also different slope. This, we'll call it a cross slope. Cross slope. Normally, this is 2% and this is 5% per AASHTO. We have a very important book. It's called AASHTO. We're going to see it this afternoon. The American Association of State Highway and Transportation Officials, which we call it the Green Book. Green Book. Okay. The geometric design for highways and the streets, and they have standards for streets and highways to make it safe to the public and to make it uniform across the state. So we're using, so this is a lane or lanes, and this is the shoulder, and the shoulder has a higher cross slope, 5%, and we're going to do calculations, by the way, today related to this cross slope in just a minute, okay, after we cover the volume computations. And if I'm not mistaken, the last problem they added in the new NCEES, the practice exam, the FE practice exam, I believe the last problem 100, to see if this is a new book. I believe this is a new book, if I'm not mistaken. Yeah, this is yeah, here it is. Here it is. Of the problem 100, for example, 100 of this white book, the FE Civil Practice, published by the NCEES. For example, here, this is a cross section. A drawing of a roadway cross section is shown below. The arrow with a number indicates what? So this is what I'm talking about. This arrow here, and we put the number. We put, for example, 2%. Or sometimes we put it that way, is 0.02, like this. This is the same as 2%. So this is correct and this is correct. Normally we prefer the percent, but he gave it to you like this. Okay. So that means that is the arrow with a number indicates what? This number here indicates the thickness of the surface coating. No. Okay. The slope of the roadway is 3 inches per 10 feet across the slope, or the edge of the roadway will receive a chamfer of a 1/4 inch or a groove ground, okay, into the surface of the road are a 1/4 inch deep. Okay. So what do you think? And again, they give you 4 possible answers, and you need to make sure that you are picking what is the best. Okay, and some answers, by the way, sometimes they confuse you by making very okay. So if you look to the solution, and I'm looking to the solution, here it is. The arrow and the number, so it is 3 inches in 12 inch per foot, okay, as 0.2, okay, over 10 feet, and he put it and he calculated, okay. So the slope of the road or a bridge cross section are expressed in foot per foot, are normally represented by a number, in this case 0.2. The slope can be expressed as a percentage. Here it is the 2.5%. So it could be 2.5%. Okay, so this is called the cross slope. The cross slope, which is basically, as we're going to see, okay, so this is a cross slope. So if this lane, by the way, and we're going to see this today also, if this lane is 12 feet, 12 foot, which is a standard lane width, okay, we call it L sub W, lane width. Okay, so and this is as given 0.025. So this point here, it has an elevation. Let's assume this elevation here is 692.45 feet. Because the contractor should know that if this is a center line and this is a profile grade, we call it PG. This here is called PG, a profile grade. Sorry, I'm using a lot of abbreviations, and you will be able to recognize all these abbreviations by repetition. So if this is a PG, profile grade, which is the location of the vertical alignment, we're going to see today. So the PG, this is the vertical alignment. Vertical alignment, which is basically vertical curves. We're going to see it this afternoon, vertical curves or vertical alignment. Vertical alignment consists of vertical curves and tangents. So right now, if this is 12 feet, okay, how much is this elevation here? The elevation of the, we call this, by the way, we call it, this is ETW, edge of traveled way, and we call this edge of shoulder, ES. Some book, they call it E sub P, edge of pavement. But ES is the right name, or the correct name that commonly used. Edge of shoulder, the edge of shoulder, or edge of pavement. This is ETW, edge of a traveled way. ETW, 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 edge of a traveled way. ETW. So if this elevation is given to be 692.45 based on your profile, or based on the vertical, or a profile, by the way, sometimes we call it a profile, which is a vertical alignment. Profile, vertical alignment, vertical curves, all these are, okay, they mean the same thing, okay? So basically this distance, that 12 feet, is measured horizontally. Shall we consider the slope? Yes, but the slope will not make too much difference, in fact, okay? So I will say that this elevation here is 692.45 minus 0.025 times 12 feet. This will give me the elevation of this one. This is lower than this to ensure that the water will run. Normally, we do this in order to ensure that the water will run, okay, and it will not stay on the lane. So the slope and the cross slope and all these things are very important, and I will repeat them again. Let's go back again to the chapter of surveying. I was talking about 192, and I will repeat a lot of things that will be repeated again. So it's called a side slope. This is a side slope. This is what I meant. Side slope. Okay. So side slope, basically we need horizontal and vertical, and always, by the way, always the horizontal. If you remember this, I said 4-to-1. The minimum right now is 4-to-1. 4 horizontal, 1 vertical. Okay, so the horizontal is much, much bigger than the vertical as far as the side slopes to ensure stability, soil stability, and also for safety of the public because of accidents and so on. So here it is. It is 2-to-1 because right now, if this is 4, so what is left here out of the 4 is 24. So this is 12 feet and this is 12 feet. And the vertical is 6. So basically the horizontal distance is 12 feet and the vertical distance is 6 feet. So this is going to create a side slope of 2 horizontal, 1 vertical. This is how we calculate. So this is the 2H and 1V. So, and here it is, the answer is, and I said that I draw a sketch. I highly recommend you to draw. Okay, problem 9-9. Everybody is awake and everybody is thinking about surveying only. Okay, I have 2 shapes and they need the area. Okay, so the area of this figure here, figure 1, and the area is in square foot. And again, the dimensions here are in what? In inches. So are using this to indicate inches, or sometimes they say inch like that. They write it down. Or so this, so I said that I can divide this into 2 areas. This is a trapezoid, and this is half a circle. Here it is. Composite area. So the area of trapezoid is so easy. This, and this will give you inches square. But I know foot square is equal 144 inch square. This will 1.14 units. Units. The common mistake that we do. Common units, okay? And probably some of you heard me before or listened or took a class with me before. And NASA is a great agency, but one time they lost satellite because of the units. To the best of my knowledge, units, it was from the English to metric, so they lost satellite. Was very expensive because of units. So don't misunderstand me. NASA is a great agency, but they are a human like us. We do mistakes, but they review everything, not once, not twice, 3 times, but because it's just so. But units, so we don't like to lose the exam. How much they charge for the exam nowadays? 225 for the exam, I believe. Or they reduce it. I believe they reduce it to 175. They give discount nowadays. Okay. So so we don't like to lose the exam because of units. Okay. So NASA lost a $10 million satellite because of units. We don't like to lose the exam because of units. Just, I needed to remember. I can remember what was the current price or what is the current price. It doesn't matter. It doesn't matter, but because the time is more valuable than the money nowadays. Okay, time is money, and especially you are going to stay away from the family, and the family will complaining, my God, when you are going to finish the FE? Then you need to tell them, wait a second, it's not just FE only. After the FE, I'm going to go for another exam. It's called PE. Oh my God. So, but let us just take one at a time. Let's finish this first, and after that, go to the second. Okay. The problem 9-10, which is the following problem here. This is the second figure. We need the area of this figure too. Again, we are missing this portion here. Okay. So it is the area of a circle. Assume this is a complete circle, and I'm going to deduct the area of a sector. What is a sector? In math, we are going to see that this is called a sector. There is a sector and there is a segment. This is called a sector, by the way. This is called a sector. So this is, I need you to be familiar with the, so here it is. And again, units. Bingo. Okay. The following section is talking about the area by coordinates. Coordinates, which, as I told you, that crisscross. So this is another name. The NCEES, they call it the area by coordinates only. So if you see on the exam, let me get the section here. to make sure that here it is, the area by coordinates. Okay, this is on page 307, as I mentioned. They call it coordinates, but if you see on in the problem, uh, coordinates is a standard name, but some surveying books they are using a crisscross. I need you to know that two facts, okay, two facts about this. I call it. Let me write it down. Okay. At least you can write it after me. Okay. Okay. So the area by coordinates, area by coordinates, fact number one. In order to do it right, this method will give you twice the area. Will give twice the area. So you have to divide by 2. So this is fact number one. When you calculate the area, don't forget the 2. The 2 already built in the equation, but sometimes we forget that. But I need you to know that this method will give you twice the area. This is fact number one. Fact number two, in order to do it right, fact number two, you must repeat the coordinates of the first point. Repeat the coordinates of first point. It translates into English, Dr. Mansour. Here we go. Because again, we need to make sure. And I will add another fact, by the way, because it came on the exam and it was confusing. And let me add it immediately. At least I will not forget. Fact number 3. And I will spell the fact number 3 on the following page. They are saying that if you do have a closed polygon like this is a closed polygon. I'm selecting a very simple shape, but we're going to go over some problems. So if this point A and this point B and this point C and this point D, and the coordinates for point A minus 3 and 6. And the first coordinate normally is the north, and the second one is the east. Okay, so based on this, our coordinate system, this is the north and this is east. And as we know, this is south and this is west. So when we put the coordinates, okay, so the first coordinate, okay, if you decided to use X and Y, but the book or the NCAA, they are giving you the X and Y. Okay, X and Y. This is why I need to also to be familiar with that. So this is Y and this is X. Okay. So this here is Y and the second one here is X. And we are going to use the X and Y since the book or the NCAAS, you're using X and Y. Okay? So if this area, if this point is 9 minus 3 and 6, and this B, for example, okay, is minus 3 and 9. And this here is minus, okay, 1 and 12. And this is, okay, 6 and 14. Assuming that these coordinates are given. The way we calculate the area, I will start with the coordinates of point A. And we arrange it that way. I will say that XA, YA. Okay? And I will do two different ways. I will go to point B, XB, YB. And XC, YC. XD, YD. Fact number 2, the one I wrote, you have to repeat the coordinates of the first point. So these two coordinates here must be repeated here again. So this is XA, YA. So these two must be, this is a requirement. I can put them vertically like this or horizontally. Somebody may say, why did you start with X? Can you start with Y? Or you can put it that way. I will say YA, XA, YB, XB, YC, XC, YD, XC. And after that, I will repeat the first two coordinates, YA and XA. These two coordinates will be repeated again. This is correct and this is correct. So it doesn't matter if you start with the X or with the Y, as long as they are consistent. So this is correct and this is correct. I need you to be aware of that. Okay? So this is correct and this is correct. As long as I enter the coordinates with the same order. If I start with X, I have to start with X for all of them. If I start with Y, I have to start for Y, all of them. And don't forget, the first two coordinates must be repeated. After we put these coordinates like this, whatever the numbers, okay, I do something, and I need you to pay attention to this. And this is, he gave you the equation, but I need you to understand this. What we do, because one little tiny mistake, if you did it on the exam, or if I did it on the exam, this mistake. So what is a coordinate method or a crisscross? We multiply this time this, and this time this, and this time this, and this time this. So the area for this area, the area, sometimes we use the A for it, okay? Basically, it is 1/2, because we said that this will give you twice there, so I have to divide by 2 and open a bracket. I will take the first, I multiplied XA, YB, a plus, XB, YC, a plus, XC, YD, a plus, XD, YA, and they close the bracket. This is the direction we call it a plus. So I multiply this time this, this time this, this time this, and this time this, and add how many coordinates points here I have? 1, 2, 3, 4. So how many multiplications I have? 1, 2, 3, 4. If you got some more than 4, that we did a mistake. I didn't finish it. I will say minus, and let me use different color. Hopefully I can find different color. Here we go. Minus. I'm still within the big bracket. Minus. This direction here is a minus. This is a minus. And this is a minus. And this is a minus. And this is a minus. I multiply XB times YA. A plus. I put the minus outside. The XC YB. A plus XD YC. A plus XA YD. Close this and close the big bracket. So there is a plus direction and there is a minus direction. The plus, I add all of them. These are the pluses. If you like to put the plus here, I have no problem with that. And this is a minus. Take the difference between them and you divide by 2. If you started with Y, I have no problem with that. It's the same. Which direction is positive or negative, it is up to you. It does not make any difference. Okay? But normally, if you can stick with this, would be much better. Okay? At least, okay, we agreed on that. So this like this, this like this, this like this, this like this. And I will call this a plus. And this is a minus. This is why they call it cross-cross, by the way. Criss-cross, minus. This is if you arrange the coordinates vertically. This is vertical orientation. Can you do it horizontally? Yes. For example, can I say that this is XA, YA, and this is XB, YB, XC, YC, XD, YD, and don't forget to repeat the coordinates of the first one, XA, YA. So these two coordinates must be repeated again. And in this case, it is this time, this is a plus, 4 multiplications, and this is a minus. This is a minus. And also will give you twice the area. So this is correct, and this is correct, and this is correct, as long as you maintain the order. Okay, XAYA, XBYB, XCYC, XDYD, and you repeat the XAYA at the end. Don't forget to have to repeat, and after that, designate direction to be positive. The area at the end, by the way, may be the negative larger than the positive, and you end with the negative area. There is no such thing as called negative area. This depends on the direction. We take the absolute value. So I don't like you to be surprised that if the negative products larger than this, okay, it depends on the direction. Okay, so don't worry about it. This is the best way that I teach it for the class, and I will look to the equation that I will examine the equation. For example, this is 0.1. Okay, this is x1 y1, and this is 0.2 x2 y2, and this point number 3 x3 y3, and this is point number 4 x4 y4, and point number 5 x5 y5. I started with X. If you like to start with Y, but normally, okay. And this, how many points? We have 5 points. So we arrange them this way. I started with Y. I have no problem with that. Y1, X1. I have no problem with that. Okay. Y2, X2. If you would like to put this here as Y1, X1 and keep the same, and you can put it horizontally or vertically. But the most important thing that X1, Y1 or Y1, X1, it must be repeated again. And I put this here in a form of note. The first two coordinates must be repeated. And I mentioned that this will give you twice the area. So you have to divide by 2. Okay. So you can put this horizontally or vertically. As you can see here, the vertical Y1, X1 and Y1, X1. They repeated. This is the equation that is given in your book, in the NCEES. Here it is. That it is XA, YB minus YN. YN, this is the last one. Plus XB, YC minus YA. Plus XC, YD minus Y. And after that, they divide by 2. This divide by 2 because it is twice the area. And we need to guarantee this problem because it is easy and straightforward. And this is the equation. Okay. He arranged it that way. This is the NCEES. NCEES. But be careful. This is YN minus 1. Be careful. Okay. NCEES. NCEES. My preference is my equation, which is came from what? The 1/2. You can put the 1/2 at the end, by the way. It's not a big deal. And I have here, these are the pluses and these are the minuses. But I put the minus here. And I said that Y1, X2, this I did this YX2, Y2, X3, Y2, X3, and so on until YN times X1. So I finished. And N is the largest number, which is in this case will be 5, because we have 5 points. This is a plus. And after that, I subtract minus X1, Y2, here it is, and so on. So one direction is positive and one direction is negative. Which one is positive, which one is negative, it does not make any difference. But as long as you keep consistent, okay, order of coordinates. If I start with Y, I start with Y, all of them. You start with X, X, all of them. If you start with north, start with north. Start, and so on. This is an easy, very easy, if you like to stick with this equation, which I believe this is the only thing that you are going to see on the exam, and we are going to solve a problem, and you are very welcome to, okay, to solve it by whatever method. I was helping a friend of mine. He preferred my method. Is easy and straightforward, okay? But it is up to you. And let me grab a question from one of you. Say that first bracket, okay, last term is wrong. Mine, I copy it wrong. Maybe it could be a typo. This is exactly as the NCEES. Let me see if I wrote something here wrong. I don't know which one you are referring. In your notes, in my notes, okay, let's look to my notes. Probably I did something wrong. Let's correct it immediately. Okay, so it is 1/2 XAYB plus XBYC plus XCYD plus XD X D Y A. Yeah. This is X D Y A. Okay. Sorry, here it is. X D Y A. That's correct. And after that, X B Y A, X C minus X B Y B, X D Y C, and X A Y D. That's correct. So this is a typo here that, or the mistake that our friend. Thank you very much. So this is X D. Okay. Y A, which is the last X D Y A. So I put X A. Okay, so so please pay attention to this, and it is very easy and straightforward as long as um, the most important thing, which is the fact number 3. Fact number 3: if you have a negative coordinates. If you have negative coordinates, enter them with the negative sign. Don't change it. So here, this is the northern and this is eastern. So this is N and this is E. Okay. If you like to call this is X, using X and Y, I have no problem. So northern, so this is east, which is the X, and the Y, which is the northern. I arrange them this way. Look, it is 520, 350. So I am putting what? I am putting N, E. Or I am putting Y, X. And the second one, 850 and the 350. And minus 450, you have to enter it with the sign. Okay, a plus 950. Negative 450, 700. And don't forget that the first two coordinates, they are repeated again. Here we go. I will put an arrow like this. And there is a minus here. And don't forget the half. And the area could be in acres. These coordinates are in feet, so we need to divide by 43,560. Because 1 acre is 43,560. Who said that? As I told you at the beginning of the book, on page number 1, you will find that the one I was referring to, on page, in fact, on page 3, you will find that on page 3, 1 acre is 43,560 square feet. Here it is. And I'm sure that all of you remember that. So if the minus, okay, greater than the pluses, don't worry. The area will take the absolute value. So the absolute value. So if you end it with a negative number, don't say, oh, what does it mean negative area? No, it's just the direction and the order that. And if you miss one number, it's going to be really a big loss during the exam, and we don't like to do that. And even I noticed that this here, make sure that there is a typo here, probably. Let me make it very, I'll review it, because right now I'm saying that this is 39.83 acres, which is the answer B. Okay. So this is I need to look to this to see, okay, did I divide by half or not? Because the half is here is correct. Because this answer in, I'm saying the answer is A. No, I need to review this to make sure that probably, because this is twice this, and probably what this what I meant. I will review it one more time. Okay, I will review it one more time. It is so these are the product, 4 products, okay, minus, and this is a plus. So it is 1752 minus this, the minus, so it is the total, okay, and 1/2 divided by this. Let me bring my calculator very quick, the other calculator. So I believe there's a type here, it could be, so this is 1718 and 1752 plus 0.5 times, so 1735, that's correct, and 43,560 divided, and 100, okay, so 173,500, enter 43,560 divided, so 39. So this, the answer is B as in boy. Okay, and I will review it one more time because here it is. Okay, so the product here, but this minus is a part of the equation. Okay, but this minus here, because some coordinates are minus, so this is the sum, by the way. This is the sum. This is the sum. Here it is. If you add all this, we ended with this, ended with this. So minus will be plus, and take half, and you divide it. So I believe probably I rearrange the answers. So it is 39.83 is the correct one, and I will double check, and please check it, and just in case. And I have many problems in my surveying books. Okay, but again, we need to understand the concept. You can arrange it. If I were you, I would try it. Okay, and different. If you start with the eastern directions, you will get the same answer. Make sense? Let us do that. I will double check this. Let me put something here to make sure that we are normally the first draft of the book normally, and I need somebody also to review my books. Then the new engineer, hopefully he will have time. The second method that they discussed it is called area by trapezoid, the rule. We know the area of a trapezoid. The area of a trapezoid, very simple. Okay, so in this case, I got, okay, so it's the same answer, okay? So the answer is B as in boy. You got the right answer, okay? Okay, as long as we agree, that's good news, okay? So no problem. Let me know, please, if there is any. Okay, so a trapezoid, obviously, this is an area by the trapezoid rule. This is a trapezoid, okay? So basically, we have a reference line, like line AB. And here are stations. This is station 00, station 0 plus 50, station 1. Station is a distance, okay? Station is a distance, and we're going to see that. So in this case, the area will be like this. The W, which is the width, okay, here it is the width, and this is a common interval, mean that the width is constant, that every 50 feet, this is 50 feet, and this is 50 feet, and this is 50 feet, or 50 meters, it depends on the units, is a station. A station is 100 feet, a station is 100 feet, or 100 meters. And half a station, obviously, it is 50. This has H1, H2, H3, and so on. And this is the equation that is given. Which is the same equation, I believe, in the NCEES. Let me make sure that normally I try to use the same notations they are using, because I don't like you to be confused. Yeah, here it is. So this is exactly, I'm using the same notations they are using for a trapezoidal rule. This is the NCEES equation. So this is easy and straightforward, and you'll find that I solve a problem. Okay, and here it is, problem number 9-12. I use the same figure. Let's calculate the area between A and B. This area here, so I'm using this, and here it is. Okay, square foot or square meter, or the area by a trapezoid with different intervals. So this distance here is not constant. Here, the distance was W, which is 50 feet in our case. But if this distance A and this is B and so on, and this is C and this is D, so these intervals are not equal. And instead of using a straight line, okay, we have a curved boundary. So in this case, the distance from here to here is 60, and from here 60, and this 140, that means this is 80 feet, and so on. So we calculate the difference between two consecutive stations in order to determine the distances A, B, C, and so on. But this is of unequal intervals, and he might ask you about that. Make sense? So I needed to be aware of that. Okay. So this is the following method, which is Simpson's 1/3 rule. This is the equation that is provided, where W is the common interval or common width. Okay. And N is given here, and this is 1/3. Okay, which is, and I obviously divide everything by 1, which is 1/3. Here it is. This is the equation. And here I took this illustration here, and we plug the numbers, and we ended with this number here. And the approximate solution using the area trapezoidal will give you 3600. But if you use the trapezoidal rule, okay, in this case, we are going to get 3600, which is, as I said, that. So the 1/3 rule will give you 3588, and the trapezoidal rule will give you 3600 as indicated here, just to compare these two. Okay. So I need you, please go over these and let me know if you have any question about this. I included something about the planimeter, even is not mentioned in the NCEES, but I said, let me go. A planimeter is an instrument or a tool that we use it in order to calculate the area. And this is an example. I do have the mechanical one. There are some digital nowadays, but basically this is a planimeter, very old instrument nobody is using nowadays because of the technology. So basically this is the lens. So if I do have a map, I must have a map. And the map, as you know, it must be a map drawn to a certain scale, map scale, and we're not going to cover it here. Okay. Basically, any parcel or any area that is drawn in the map, I can calculate this area by tracing the boundaries of this by rotating clockwise. Okay. So, and I'm reading this. This is something called Vernier scale. Very, very old method, but still they're asking the people who are taking or the engineers who are taking the exam for California PE, they're still asking them about the Vernier scale and explain how to read the Vernier scale. No, nobody will ask you. Nowadays we have digital, but they're still asking what is a Vernier scale, Vernier scale. So I give you a little bit of, I said that the area of a lake is obtained by a planimeter, and it was found to be 10 inches square on a map that has a scale 1 to 50,000. This is 1 inch is equal 50,000 inch, or 1 foot equal 50,000 foot. This is 1 inch on a map is equal 50,000 inch on the ground, or 1 foot on a map is equal 50,000 on the ground. So this is the scale. This what does this mean? And I explain it here. Since I have 10 of them, 10 inches square, so I multiplied, okay, by the 10 inches square, 1 inch square equal this, and you divide by 5280, because he need the area, by the way, in square miles. Again, this is another, okay. So this is the planimeter. The last set of equations provided in the NCEES is related to the volume. And he gave you 3 sets of equations: the average in the area method, the Prismodial, and the 1/3 rule, or as we call it, the pyramid, okay, or the prism. And I'm going to page 307. So the average in the area, the Prismodial formula, and the pyramid or the cone. Those are the 3 methods that they are discussed in the, or they are included in the NCEES to get the earthwork formulas. Okay, so here are the equations, but probably I did not include the prism for a reason, unless I separated differently. No, I will add the prism here to make sure that we are including this. So I will add the prism or the pyramid, which is they call it the 1/3 rule. Pyramid, I will add this to modify it, and I will be glad to send this to you. Or cone, pyramid or cone, which is the volume is equal 1/3. Let me see how they write it. Okay, it is, they said now h. They put h first, which is height, times the area of the base, and they divide this by 3, which you call it 1/3 rule. So I will add this here to include the 3rd method, which is the pyramid, okay, which is the volume is equal the height and the area of the base divided by 3, which is a 1/3 rule. Let's just take a few minutes to break. Right now is about 10:10. Let's come back after 10 minutes from now to continue our discussion about volume computation. Earthwork and volume computations is another area, okay, that they expect you to be familiar with. So 10 minutes from now, thank you. Okay, welcome back, everybody. The NCEES practice exam, they have a problem number 50. He gave you the cross-section or cross-sectional areas that to be excavated at a certain section of a road project, give you stations, and he already calculated the area, and is asking using the Prismodial method. So here he specified the method to be used. The volume of the earthwork to be excavated in cubic yard between station 4 plus 35, which is this one here, and station 5 plus 65. So between these 2 stations, he would like to get the volume of the earthwork and in cubic yard. So the 3 methods that mentioned, the average in the area and the Prismodial formula and the pyramid or the 1/3 rule, the most important thing about the Prismodial, the A sub m is the area of the midsection, and it must be the computed area. It's not the average of the 2, by the way. It must be computed. And you will see this on the following table. I have here a table 9.6, just talking about the cross-section method, okay, the borrow bit volume, and the contour methods, that method that we use. So these 3 methods, we are here talking about the cross-section methods only, the average in the area, Prismodial, and the prism, which is the 1/3 rule. I took each one of these and I draw something for you. The average in the area, So basically you have two areas, area at the beginning and area at the end, and they are separated by a distance L. So the volume is equal A1 plus A2 divided by 2 times L over 27 if the area is in square feet as indicated here. It could be in cubic meter also. So this is called the average in the area. You add these two areas, and I need you to be aware of advantage and disadvantage of each method. This method, by the way, gives approximate and larger volumes, always overestimates this method. It ignores the slopes and the orientation of the ends and the sides. You can increase the accuracy by decreasing this distance. And obviously it favors the contractors because obviously it overestimates. And we use it also for the wedge. We're going to see a table in the following page it does. So this is called the average in the area method. The second one is called the Prismodial. So they said instead of relying on two areas only, we're going to come halfway. So this is L over 2 and this is L over 2. So this is L over 2 and this is L over 2. Halfway between the two areas, we're going to get another area in the middle. It's called A sub M. But the A sub M, it must be computed. It's not the average of these two. If you take the average of these two, we did nothing. We went back again to the average in the area method. In fact, this method, by the way, the Prismodial, it gives more accurate and less volumes, by the way. This way it favors the owner. And the difference between the volume from the average in the area method and the Prismodial, they call it a Prismodial correction. Prismodial correction. And this is the equation. It is L over 6, A1 plus 4AM plus A2, and the 27 is just a conversion. So this is called the Prismodial method or the Prismodial formula method. Or the third one is the pyramid or the prism, which is the 1/3 rule. The 1/3 rule, we use it when one in the area is equal 0. This area must be 0. And the area of the base is known. This is the area of the base. So they call it the 1/3 rule. 1/3 rule, okay? Or basically the volume is equal the area of the base times L divided by 3 and the 27. And these are the three equations given in the NCEES. If the other in the area is not 0 like this, like a truncated cone like this, or a truncated pyramid, there is another equation I included just in case. And in the material section, if you go back to the previous chapter I gave you, if you remember the slump cone that we used, I calculate the volume using this equation, which is called the truncated pyramid or the truncated prism, which is L over 3, the area of the top, plus the area of the bottom, plus the square root of this product, which is. So if you would like to remember this, because it's not given, that's fine. If not, if you have an area that's really small, and you can use the 1/3 rule, but it will not give you the exact or the accurate as the truncated cone. We have something called wedge. What is a wedge? Like when we have the ramps, we have an area at one end exists and the other area is 0. So even this area is 0, we are still using the average in the area method, because this is a wedge, is not a prism. A prism means that all the points are meeting at a common point like this, like a pyramid or a prism. So we are using the 1/3 rule here and the 1/3 rule. So I need you to be aware of the difference between the prism and the pyramid and the wedge. Okay, the wedge, we are still using the average in the area method. This problem here, for example, he gave you stations and he calculated the area of the cut and the fill. The following data of cross section for a given. Okay, so station 1 has 0 cut and 50 fill and so on. What is the amount of the imported borrow or waste, which excess? We have something called imported borrow. When you get some soil from outside in order to build the project, we have local borrow and the imported borrow. There is two different terms. I need you to be aware for your knowledge. So this is page 3. So any project, okay, we have the original ground, the OG, the original ground, OG, which is the first thing that we do. We survey the job and get the DTM, digital terrain model, for the original ground, which is, I need to know how it looks like the ground. And after that, as an engineer and as a designer, you design the profile, whatever the profile is. This is your choice. Normally, we try to make it balance, and it depends on many constraints. So this is a profile grade, which you call it BG, a profile grade, or the vertical curve that we design. So we do have series of cut and fill. When the OG is above this, so this is cut, you have to remove all this to build your road. Cut, cut. Okay, so these are C. And we do have fill. Okay, when the OG is below, so this is F, which is fill, and this is also fill. We try to do our best that cut equals fill. We call it balanced job. Balanced. But if the cut is greater than fill, that we have excess. Or sometimes we call it waste. Extra soil, we call the cut. If the cut less than fill, that we do have a deficit. Or we call it borrow. We need to get soil from somewhere in order to build the job. And as an engineer, you do this, and there is a tool that we cover it in the AM, or for the PE, and for the surveying, a tool is called mass diagram. We're not going to talk about it here. It's not required. Mass diagram, that it will give us the condition of the job, if it is balanced, or we have a deficit, or we need to get, or we have excess. So, but those are the three conditions that may exist in any job. We try always to do our best to balance the job where the cut and the fill are equal after we make all the necessary adjustments. Because the fill, by the way, when you have a fill or embankment, okay, so this is C, letter C here, cut, and this is F. When the contractor is going to build the road for you or for your agency, okay, this is OG, this is fill. Sometimes we call it embankment. Embankment. They put it in layers. We call them left or lefts. So left 6 to 8 inches, and we compact it very well to the 95% compaction. We are going to talk about this in soil mechanics, compaction, using a Proctor method, or modified Proctor, and we build layers after layers until we build the road. We need to make sure that you compact it very well so it will not settle. So the soil will shrink. So the cut, when we take the soil from here and put it here in the fill, when you cut it, it will increase in volume where it swell, and after that, when you put it here, after you compact it, is going to shrink or is going to be compacted. And we need to know that there is a swell factor and the shrinkage factor. We're going to see that. So these are the terms. So imported borrow mean that IB, sometimes we use the abbreviation IB. So we need to calculate the volume of the cut and the fill. Here he did not tell you which method. Here in this problem 916, I did not tell you which method. Automatically we use the average in the area. If it's not mentioned here, or mentioned here using the average in the area, that's good. If he did not mention it, I will use the average in the area method. This is the default. Okay, default. In the surveying book, I did not mention the mentioned, but here I specify the method. Okay, but if this using, it did say that without mentioning, so the average in the area method is for the problem that he mentioned here, or he gave it here, he is specifically, he said that I needed to use a Prismodial formula. So we're going to solve it also. So I need to calculate the volume of the cut and the volume of the fill and take the difference. So the volume of the cut, I got 0 plus 250 divided by 2 times 100, which is divided by 27. 250 plus 100, straightforward. Don't forget the 27 because we need it in cubic yard. And the areas here are And this is the station. Between here and here is 100 feet, as all of you know. And from here to here is 100 feet also. So we calculated the volume of the cut and the volume of the fill, and we get the net volume, and we got, so the volume of the cut is better, more than the volume of the fill. So we have cut greater than fill in our case. And that's why we selected the answer C, extra soil. As I said, that the soil will shrink under compaction, and it will swell if we excavate the soil. So they have something called the swell and the shrinkage. And this is figure that it's available in almost every surveying textbook. This is called bank cubic yard, which is the original soil before disturbance. After we excavate it, it will swell. So we call it loose cubic yard, LCY. And after that, after we place it and compact it with the heavy equipment, and we spray the water or put some water, okay, to achieve the optimum moisture content, we call it compacted cubic yard. So CCY. So there is BCY, LCY, and CCY. I need you to be aware of that. There was a diagram I drew it for you when we talked about concrete mix design. Do you remember concrete mix design? And I told you there is another diagram similar to this that will come when we talked about earthwork. The diagram for the concrete, we said that this is SSD, and this is the dry, and this is wet. And as you remember, I said from the dry condition, either air or oven dry, to reach the SSD, we call it SSD moisture content. And from here to here is the moisture content. Or sometimes we call it water content, as in the NCEES content, and we use the letter W, if you remember, lowercase w. This is the diagram that I drew maybe one time or two times, and whatever the number. There is a similar one for earthwork. And if you understand these diagrams, I believe you will be in very good shape and you will be able to solve. So this is for concrete mix design, the one we did it last meeting. Now we are talking about earthwork. So the earthwork, here we are talking about similar, but here we call it, this is loose cubic yard, and we call this is bank cubic yard, and we call this compacted cubic yard, CCY. And from here to here, from bank to loose, we call it swell factor. And the swell factor, by the way, is equal 1 plus swell percent. And the swell percent will be given to you. And from here to here, we'll call it a shrinkage factor. And this is equal 1 minus shrinkage percent. I need you to know that the swell factor is greater than 1. 1.15, 1.2, it depends on the type of the soil. So 1 plus is swell percent. The shrinkage factor is less than 1 in all soils, except greater than 1 in case of rocks. When you blast rocks or disturb rocks, you cannot put them back again as God created originally, so there will be some voids. This is why the shrinkage, rocks cannot shrink, okay? They are increased in volume, in fact. But for less than 1 shrinkage, this is for sand, clay, silt, or any kind of mix of these soils, you'll find that the shrinkage factor is less than 1, okay? It could be 0.85, 89, something like that. So it is 1 minus, and the shrinkage percent is different from shrinkage factor. I need you to be aware of that. And the swell percent is different from swell factor. Okay, so the shrinkage percent, this must be given to you. Don't assume it. Must be given. And also the swell percent must be given in the problem statement. We have a range, but must be given in the problem statement. So because they might ask you to convert one status or one volume status to another volume. Okay, so this is the bank, and this is the loose, and this is a compacted cubic yard. Compacted cubic yard, by the way, this is a final product. This is a finished product. That when I build embankment like this, it must be compacted cubic yard. Because as I told you that they put it in lifts and they compact it to 95% or 92% or 98%. It depends on your agency or it depends on the specification. So this is a finished product. Because after that, we are going to open this road to the public and the trucks will be and the loads will be here. We don't like this embankment to settle or to shrink because this will be a serious problem. Okay, so I need you to know or try to remember these two diagrams. I came up with these diagrams and I found them. They are very useful in understanding the concrete mix design problem and problems or the earthwork volume computations if there is a shrinkage or a swell factor included in the problem, and you need to make the adjustment for the volumes because we need to know that. And for the PE, we cover this in depth, and I cover this in depth also with the surveying group. So this is the loose cubic yard and bank cubic. I define it for you. What is a bank cubic yard, loose cubic yard, and compacted cubic yard? I define each one of them, and these equations are the relationships between. So from one volume to another. So it is okay. There is something that's called load factor. We use it for construction, which is 1 over swell factor. Probably in the future, there's no need to add this. I will modify this to make it shrinkage. But the compacted cubic yard is equal the bank cubic yard times the shrinkage factor. And the shrinkage factor is 1 minus shrinkage. I need you to write this, please, shrinkage percent. And the swell factor is 1 plus swell percent. Okay, so converting from one volume to another, you might be asked about that. Problem 917 is talking about, I do have a cross section for a road, okay, and the side slopes 4:1, which is the minimum required. Okay, for fill. For cut, we could make it steeper than that, by the way. Sometimes we can go 2:1. It depends on your agency. It depends. 2:1, we know for cut. This is a cut, by the way. This is cut. Called the OG and, okay. So the section of this cut is 3,500 feet long. So the length, okay. The mass diagram, as I told you, as a tool, we use it to know the status of the earthwork, if we have cut more than fill or cut less than fill. So indicated that we need additional 2,000 cubic yard borrow. So in order to avoid get borrow from outside, it's called imported borrow, the designer decided to lay both. So instead of having 4:1, I will make it flatter in order to generate the 2,000 cubic yards. So basically, I need to get the volume. So the volume, by the way, if you look to the 3 equations that they provided, the volume, we remember this from high school, the volume equations, any volume equation, volume is equal area times length, or area times depth. This is the volume that we learned in high school. If you remember the cylinder, if this is H and the diameter of the cylinder is D, so what's the volume of this cylinder? Volume is equal by D square over 4 times H, which is basically the cross-sectional area. The area here means cross-sectional area. You understand? Time the height, or time the depth, or time the length. So the same thing for the average in the area method and the Prismodial and the 1/3 rule. So the volume computations is still based on the basic equation that we learned in high school, as all of you know. So going back to this problem here, so the volume is basically, if I can find the area of this triangle and multiplied by the length, and I have 1 on the other side, so I have to multiply by 2. So this is the 2 here, by the way, and this is 1/2 base times height, and this is the length, and this is, so I can find what is the volume equivalent to 2,000. 2,000 is given, by the way, in the problem statement. And is asking, after we do this, what will be the new side slope? Horizontal and vertical. So if I can get this dimension here, very easy, I can, or if I can get the dimension BC, I can calculate, and this is the dimension or the length of the BC. After that, we can convert it horizontal and vertical, and it came out to be the answer C, which is, became a flatter, obviously, instead of 4:1. Obviously, the answer A is out, because we know the slope, 4:1, will make it flatter, so the horizontal is getting bigger. So by the process of elimination, you can eliminate this answer because, and here it is, I mentioned this here. So let's go to the problem that's given in the NCEES. Okay. Here, problem 50, he said that using the Prismodial, so the volume of the Prismodial volume is equal L over 6 times A1 A plus 4 AM A plus A2. And this in cubic, this is in square foot, so we need to multiply by 27 here. Okay, so what is the length from here to here? Okay, this is the length between 435 and 565. These are stations, and we subtract them like this. We take 5.65, and I know some of you are doing this on a daily basis, minus 4.35 minus, so it is 130 feet, which is 1.3 stations, divided by 6 and 27. And the A1 here is 322 plus the 4 AM. This is the 395. By the way, this must be halfway, by the way. From here to here, it is 65 feet, by the way. And from here to here is obviously 65 feet. So this area, the middle area, must be halfway between the two stations. And this is the case here. If it's not halfway, you cannot use the Prismodial formula. So it is 4 times the middle area plus the area number 2, which is 418. So if we do this, so it is 395 enter, okay, and you multiply this by 4, and 322 plus 418 plus, do it with me at least, we can verify our math. 27 divided, I got 1861.73 cubic yard. This is my answer. I hope that this is the same you got. If we agreed on that, that's good news. If not, we can figure out. So probably the answer 1860, probably the answer C is the best one. Here he specified the method, the Prismodial formula. So in this case, you have to use the equation that given in the NCEES. Any question about that? Easy stuff. Okay. Can you do this in the amount of time that, as I told you, that you have 330 minutes, which is 5.5 hours, 330, and you have 110 divided, so as about 3 minutes 3 minutes per question or per problem. So, and you have to be selective, by the way, because you have, I believe they give you 55 questions and after that they allow you to take a break. So they give you 55 and you can take a break if you want. For those who took the exam, they are familiar with that. And they give you the other 55. So the total 110. This book here, he gave you only 100 questions. Okay. They give you only 100 questions. The question number 100, do you remember the 100, the one we talked about? The cross slope. This is the cross slope. Okay. And you need to calculate it, but basically, okay, 3 inches per 10 feet. Okay, this is 3 inches. So 3 inches divided by 12 inches per foot. So this will give you a quarter, which is 0.2, okay, 5. Okay. So you have to be, okay. And this is in 10 feet. You divide by 10 will give you 0.025. Okay, which is the 2.5%. You can say this also, it is as 2.5%. Okay, so units are very important. And so he gave you only 100, but I believe the actual exam, they give you 110. Maybe they are using the 10 questions that for statistical, for whatever it is. Don't worry about the grading. How they grade the exam is not a big deal. So the average in the area method, 1/3 rule, and so on. If you look to this problem, let me just, we have only 1 hour left. I need to finish. So let me wrap up this because I still have quite a lot and I need, and I'm sure that you are going to come up with questions. Coordinates are important. Coordinate or coordinates northern and eastern and or X and Y, if you are going to use X and Y, rectangular coordinate system, or the northern and the eastern. We are using coordinates a lot. Coordinates are useful in a variety of computations, such as determine the length and direction of lines and angles, calculate the area. Do you remember the area by using coordinates? Making certain, okay, curve calculations, and locating inaccessible points. Sometimes we have lakes, sometimes we have mountains, and we can use the coordinates in order to locate points that they are not accessible to us. Okay. The state plane coordinate system, which is known as SBCS, this is what we are using. Obviously, each state, they have their own system, but the method that they are using, there are 2 methods. One is called, I hope I mentioned them here. I did not mention them here, okay. Because the Earth, as all of us know, this is the globe. Assuming this is the Earth, I believe there is a picture coming, probably much better than mine, hopefully. Okay, assume this is the Earth. Forgive my. When they start to establish the coordinate system, there are 2 scientists. They came up with 2 approaches. One is called Lambert, conical shape, Lambert, and Mercator, cylindrical system, where they intercepted the Earth. One intercepted with a cone, imaginary cone, and after that they took this conical shape or the intercept with the Earth, okay, and they open it and or unfold it and start to do calculations. So and they establish a coordinate system for us. The first one that was used, it was 1927. It's called North American Datum of 1927, which is based on something called the Clark ellipsoid of 1866. Here it is, a Clark ellipsoid. He came up with the dimensions for the Earth, okay, the equator radius and the polar radius, and we do calculate what's known as the flattening of the Earth, because the Earth is not exactly circular, okay. And after that, they obviously, with the new measurements and the GPS and so on, they came up with what's known as the GRS, Geodetic Reference System of 1980, and where the GPS is. So the GRS 80 ellipsoid, and this is what we are using nowadays. So the datum, the old datum NAD, which is the North American datum of 1927, is gone, and right now we are using the NAD of 83, the national or North American datum of 1983. This is a current system, or this is a current, okay, datum for horizontal, by the way, because we are going to see in the following page, I believe, or couple pages, we are going to talk about vertical, because in order to locate points on the ground, or build our freeways, or build our roads, or build, so we must have reference datums. So there is a horizontal datum and vertical datum. Horizontal datum, horizontal, they mean X, Y, or northern and eastern coordinates, okay? This is a horizontal datum. So the horizontal datum that in the past we used to have NAD 1927, but this is gone. Right now we are using NAD of 1983, the North American datum of 1983, okay, where the coordinate system is based on that. This is gone because they did a lot of adjustment and a lot of, okay, measurements, more accurate measurements, and they established the North American datum of 1983. This is for horizontal. For vertical datum, okay, we used to have what is known as the National Geodetic Vertical Datum of 1929. This is also gone, is no longer, and right now we are using the National Geodetic Vertical Datum of 1988. So this is a current datum we are using, okay. In order, by the way, for you, and I hope that you will have time, or I encourage you to do it, there is a very important website. It's called usgs.gov, United States Geological Survey, okay, .gov, very, very, very useful website. It does have maps, and it's talking about horizontal datum and vertical datum. Even it's talking about seismic, talking about maps. United States USGS, very, very important website. I encourage you to, if you'd like to read more, to know about coordinate system or coordinates that we are using here. So I needed to read this, and you are very welcome. I gave you some numbers here related to the two references. The Clark-Freud of 1866. This is old one. This is old one. There is no longer exists. We're using the GRS 80, which is a little bit different. You can see the flattening of the Earth is a little bit different. I have a problem here, 918, talking about coordinates. Okay. He's saying that the coordinates of point A are given, northern and point B, and asking what is the bearing of this course. So right now, basically, you can, by the process of elimination, is very important to know that this is north, and this is south, and this is east, and this is west. So if you look to the first point A, this is northwest. It is somewhere here. And point B is the north is less than that, so it is lower, and the west is before that, so point B is here somewhere, relatively, okay, or locate them relative to each other without really. And he's asking what is the bearing of the course AB. So course AB, I'm going from here to here. So my coordinate system for establishing the bearing of this line is like this. It's different from B to A. As I told you, there is a forward and back, azimuth, and bearing as I talked. So this is a forward AB. So in this case, this is north, and this is south, and this is east, and this is west. So the bearing of the line AB is southeast. So the bearing of the line AB, it must be southeast. Do I have southeast? I have one southeast and southeast. So these two answers are out. It's called the process of elimination. So the answer A and the answer D are out. I need you to be aware of that. It's called the process of elimination. I mentioned it before more than once. A process of elimination. Where you eliminate the answers does not make sense. Because if you have only 1 minute left, okay, and you have a problem. If you can eliminate two answers, so it is 50-50. Just pick one and pray to God. That may God accept your prayer and you may pass. Okay? But if I don't know the process of elimination because I don't understand the concept, each one is 25%. So we need to learn this. And as I told, the process of elimination is powerful as long as we study. Because I know it cannot be northwest or southwest. It must be southeast, southeast. But he make my life difficult, or your life difficult, by giving you two answers, southeast and southeast. So in this case, and I need to get the angle alpha. What do they call it? I call it alpha. Okay, alpha. So in this case, I need to get the difference. This is delta west, and this is delta north. So the angle alpha is equal to the inverse of tangent delta north over delta west over delta eastern or delta western. Is not a big deal. Okay, if you like delta eastern, I have no problem. And I get the angle, and this is in degrees, by the way. You have to convert degrees, minutes, seconds. Do you remember that? But obviously, by this is 48, so the only 48 is here, so the answer is B. Even if I am not able to convert it to degrees, minutes, seconds, in this case, maybe the answers will be so close. By the way, he will give you also this is 48. Maybe. So in this case, you have to convert this to degrees, minutes, seconds. Sometimes they do that, by the way. They give you two answers are close to each other, such that you have to go further one step in order to get it. So can we get the length of this? Can we get the length of AB? Sometimes they give you what is the bearing and the length. So, and the length of AB. Yeah, it is Pythagorean theorem, as all of us know. So this is delta northern square, A plus delta eastern square. So basically, so the AB is, I got this 600 square, A plus 685 square. And take the square root. This will give you the length. Sometimes they do that. Sometimes they ask you for the bearing and the length, or the azimuth and the length, but also, by the way. The same problem could be repeated again. So it is 600 second square, and the 685 second square, and you can add this and take square root. I got 909.87 feet. So this is another. He might ask you, instead of asking you what is the bearing of the course AB, will give you the azimuth of the AB, of line AB. So the azimuth of the line AB, I need the angle measured clockwise from the north. So in this case, what will be the angle? Here it is. From here all the way up to here. This is the angle theta, for example. So the angle theta is equal what? Is equal 180 minus alpha. And I know the alpha, subtract alpha from 180, so this will be the azimuth of the line AB. Measured from north, clockwise only, as all of us know, clockwise. So the same problem could be really changed or could be modified to ask many things. He can ask what is the bearing of the line BA instead of AB, BA, and so on. I need you to be aware of all these things. forward and back or backward, forward and back, forward azimuth and back azimuth, and so on. Okay. Okay, so the following topic is talking about leveling. Leveling, this is another topic listed by the NCEES. Leveling basically is a process of determining the difference in elevation between points, or determine the elevation of a given point. So leveling is a procedure used when one is determining the difference in elevation between points that are remote from each other. This is the datum that I was talking about, the National Geodetic Vertical Datum of 1929. This is gone. Right now we are using the North American Vertical Datum, which it is of 1988. Okay, because they adjust, because this is determined, by the way, based on the MSL. What is MSL? Here it is, MSL. What is MSL? Mean sea level. There is a picture, I believe, on the following page. Yeah. The MSL, this figure here, the MSL, this is zero elevation. So the reference or the datum for the elevations is the MSL, mean sea level, which they adjusted from time to time because, as you know, the level of the sea is changing from time. In fact, they have stations. They have every 19 years. And the MSL is a zero elevation. Okay, so anything above the mean sea level is positive. Anything below the mean sea level is negative. There are some areas here in California, they are below the MSL. That's why they have negative elevation below the mean sea level. So why we need to do this leveling method, or we learn leveling? Because we use it a lot. Okay, design of highways, railroad, canals, and so on, layout, construction, calculate volume, drainage, maps, and we study what is known as subsidence. Subsidence is a very important phenomenon here. Okay, or phenomena. Subsidence, where the ground is settling down due to the extraction of oil and water. So there are some terms or definitions. What is a vertical line? What is a level line? Horizontal line? All these things are horizontal plane, backside. When we do leveling, this is called differential leveling, where you put the instrument between 2 points. Normally we keep the distance equal, by the way. This distance x must be equal this distance x, to eliminate something called C plus R, curvature and refraction. And you put the rod on top of a point of known elevation. If the point has a known elevation, we call it backside. And you take the same rod and put it here, we call it foresight. So there are two readings, backside and foresight. I need you to remember that equal backside and foresight distances, which these distances here, one is called backside distance and the other one is called foresight distance. And the backside is always taken at a point of known elevation. So the point that has elevation or known elevation, we call it the backside. There are a couple equations, you are going to see them, which is, they are very easy. When this is the elevation, if you add the backside, will give you what is known as the HI. So if you add the rod reading here, this is called RR, by the way, also rod reading, but this is a, oops, sorry, let me move my camera. Okay, this is the rod reading here. This is the rod is basically is a scale, and they have two different type of scales. We are going to see it, and this is an example for a rod, surveying rod. Okay, this Philadelphia rod, Philly rod. Okay, it's basically a vertical scale. We hold it, and we should be able to read it, and I'll show you how to. It could be a metric, by the way. This is, for example, a metric rod, a metric. Okay, the metric rod. Okay, and I will show you how to read it. And basically, if you add the rod reading on the back side to the elevation that's given, will give you the HI. If you take the HI, you subtract the foresight, will give you the elevation of point B. And here are the two equations I need you to be aware of. Equation the 922 and equation 923. These equations, to the best of my knowledge, are not given in the NCSS. They assume that you know it. They assume, to the best of my knowledge, that you know it, okay? And we should be able to remember these basic equations because they are expecting that you are familiar with the process of elevation, determination, and leveling. So I need you to remember this, that the HI, the height of the instrument, is equal to the elevation of the benchmark plus the backside, and the elevation of any point is equal to HI minus the foresight. The foresight, by the way, we call it the minus side, the minus, okay? So except there are a few situations that I don't know if I mention it here or not. The force is sometimes such that the bridge, okay, I believe, okay, let me go to the back side first. The back side, they call it a plus side. A plus side, okay? So here it is, the back side. Okay, they call it the plus side because it is added, okay, to the benchmark elevation. This one here, the foresight, was sometimes we call it minus. I believe I need to review this. So this is sometimes is minus. Sorry, minus, but sometimes it is positive, like bridges and signs. Okay, and I will explain this to you. The mean sea level, MSL. Benchmarks basically is a brass disc. Normally is a brass disc. It has information, the elevations and the benchmark number and so on. And these are public record, by the way. They are available to you. You can ask your local agency, state or county or federal. Give me the list of the benchmarks nearby. We have something called TP, turning point. Turning point, it could be just a piece of metal, you drive it into the ground, or it could be a plate, or it could be just a piece of wood like this. And we drive it into the ground, and we put the rod on top of it. Turning point is a point is used to transfer elevation, is a temporary point used to transfer, okay, an elevation or intervening between two benchmarks. I needed to know that TP, turning point, which is leveling. There are three different types of leveling. One is called direct leveling, direct, or differential leveling, or sometimes we call it spirit leveling. And another one is called the trig leveling. A trig is indirect because we are using a mathematical formulation, a trig relationship, in order to calculate the elevation of a point. But differential leveling is direct leveling because we can get the elevation directly. So I need you to know that there is direct and indirect. Under the indirect, there are two. One is the trig leveling, trigonometric leveling, and the other one is called barometric leveling. We don't use that, but I explain it here. As we go higher in elevation, okay, the pressure goes down, so we can correlate the pressure with the elevation, but it's not accurate at all. We don't use it at all for surveying. We are using this, most commonly used, and this sometimes we use that. Okay, so I need you to be aware of differential leveling or direct leveling is a very important one. Levels are instruments that, like this one here. Let me see, I have one here. This is a level. Some of you, I'm sure that if you took a surveying class in the undergraduate, you remember this. So basically, leveling, we are using a level like this. It has an eyepiece from here and telescope on the other end. This is just to read the rod. So there are different types of, it could be hand level, which is a very simple one, and we don't use this. This is for rough leveling. But the dummy and the self-leveling or the automatic, those are the most commonly used one. So basically an instrument to read the reading, the rod. The rod, there are different types of rods. One is called self-reading rod. Self-reading rod, this is like Philadelphia rod. Okay, Philly rod. There is rod they came up with called self-reducing rod. It's called linker rod. Okay, linker rod or direct reading rod. And this rod also, I have it here, but obviously I cannot really send it to you. But I do have, by the way, some files. I have some recording or some, I hired somebody and he collected a lot of surveying equipment and method. I do have it. I can send it to you. You can watch it if you want. So the other rod, which the one I'm showing to you right now, it does have a metal tape in this middle. This middle tape is moving. I can adjust it at any reading I want in order to reduce the mathematic or the adding and subtracting. This is why they call it direct. Okay, direct reading rod, because the information we can take it directly. So I need you to know these two. These two are the most common, especially this one here, we use it a lot. It's called self-reducing rod, or we call it direct reading rod, and I'll explain it to you. Okay. Here are some examples of rods. Okay. And we're going to see a picture, I believe, how to read it. Did I include this or not? No, I said no, it's not important for you guys. So, okay. So the, and I doubt that he will ask you, but basically this is 5, 6, and so on. And between 5 and 6, there are tick marks. And we take the top and the bottom of each of these tick marks. So this is a Philadelphia rod, the Philly rod. This rod here, which is Philadelphia rod. B, this is a metric rod. This also is a metric rod, but we are using for something called the stadia. This is a metric, also the one I showed you, for something called the stadia. Stadia is a technique that we use it in order to get the horizontal distance. Oh, I have it here. Sorry, yes, I have it. Okay, how to read the rod. Okay, there is a technique that we use it in leveling. It's called waving the rod. Waving. This rod, the leveling rod, must be held vertically 90 degrees to the supporting ground here, okay, in order to ensure the correct reading. Most of the rods right now, they have some kind of vial where you can adjust it to make it exactly perfect. But if the rod is not equipped with this, we are using the technique called waving the rod, waving or swinging the rod. Waving the rod means that you are moving the rod to and away from the instrument. This is where this is a level, and somebody is here is reading it, okay? So, and this is a line of sight, and we take the lowest reading. The lowest reading is the precise reading or the accurate reading. So I need you to be aware of that, just in case if they ask you what is meant by waving the rod, waving the rod. This is what you will see if you look to the telescope of any an instrument like level. You have what is known as a crosshair, one vertical and one horizontal. This is what we are really normally take the reading, but there is one other here is called top here and bottom here. We use this for another technique. It's called 3-wire leveling. So, for example, here, this is a 5 foot. So this is 5 even, and this is 5.26 because this is 5.1, 5.2. So 5.21, 5.22, 3, 4, 5, and this mark here is a 5.26. This is how we read. So each, this tick mark here, or this tick mark like this, or this tick mark like this, the way they graduated, so we read the bottom and the top, and the bottom and the top, and so on. So they mark it that way, or they draw it that way in order to, okay, facilitate reading the rods for us. And this is the one I showed you. Here it is. So this is the 2. This is 2 feet. Normally make it red, okay, to differentiate between, because there is another 2 here. This is 2.2. So they make the full mark of a foot is at the red in order to ensure that we are not mixing, okay, the numbers. So this is 2.1, This 2.2. This is 2.1 here. This here, this one here is 2.1. This is the 2.11, 2.12, 2.13, 2.14, 2.15 here, 2.16, 2.17, 2.18, 2.19, and 2.2. Here it is. This is the way we read the rod. Okay. And I'm expecting that all of you took a surveying class, and if not, this is the way we read the rod, including the top and the bottom hairs. As I told, this is called the top hair and the bottom hair. We're going to see it in something is called a three-wire leveling. Three-wire leveling. They said that instead of relying only, this is called the cross hair, by the way, the reading at the cross of the bottom, and it's called the cross hair. They came up with this technique where we read the top and the bottom also, and we take the average of the three readings, as we're going to see later on. This is what is known as the differential leveling operation. You start a benchmark, start here, benchmark 33, whatever the number of the benchmark or the name. This is the elevation. And you set up the instrument at different setups. The setup A, setup B, C, and so on, because we cannot cover the entire distance in one shot or one setup. So we have, this is the elevation, 75. This is the backside. Because this is the reading at the point of non-elevation. If 75 plus 5 will give you this. Subtract this will give you the elevation here. Add this and so on until you get the last reading here, which should match this. But we do have some errors, because surveying, there is no such thing is called absolute surveying, or there is no say that no errors. No, any surveying error, by the way, any surveying measurement, it has errors. It has errors, okay, because of, I will tell you 5. So errors in surveyor, in surveying, there are types and there are sources. The types of error, there are 2 types. One is called random errors, and one is called systematic. Okay. Random, that it will occur with a different magnitude and different sign, but the systematic, they occur with the same magnitude and the sign. It's called systematic errors. Sources, there are 3 sources of error. Human error, because we are human, we do mistakes and we cannot read everything perfect. Or personal, sometimes we call it personal, or human or personal. And instrumental error, because our equipment are not perfect, instrumental error. And environmental errors, because of the wind and temperature and magnetism and so on. So there are sources of errors and types of errors. So any surveying measurement we take is not perfect. It has some kind of error. But these errors in surveying must be within the standards. We have standards. Within the standards. Okay, it must be within, and they provide us standards, and you will see, I believe I'm providing one example for a standard table for the traverse. So, so leveling is one thing that you might see a problem on the exam. Here, something is called curvature and refraction. The earth is not perfectly flat. It does have some curvature. Okay, so, and also the refraction, where the line of sight, the atmospheric refraction, which affect the line of sight. My line of sight, when I look in the instrument, my line of sight is not exactly horizontal. It will be deflecting down. So these are the equations. Don't worry about it, but I need you to be aware of something called the curvature and refraction. These are errors that we need to account for these types of error, and they develop these equations for us. These equations are not given in the NCAAS, but I need you to know that the leveling, okay, it is necessary to consider the effects of the curvature of the earth. Usually two effects considered together, and they give you to calculate the effect. A three-wire leveling is another type of leveling that we use it in order to get the benefit of the top here and the bottom here. As I told you, normally we read this. This is a crosshair. But they said since we have a top here and bottom here, we use it for stadia. We can take also the readings and average the three readings. I take the top here reading, and this is the crosshair, and this is the bottom here. So they said that why we don't get the benefit of these hairs, so, or these. So if you look to this, you will find there are three readings here. So 0.825, and this is the sum. And this is the average, X bar. This is for the backside. To each backside and foresight, they take three readings and add them, and after that, we take the average. And we do the same process as we did before. I need you to be aware that the three-wire leveling is a differential leveling. It's still differential leveling. Differential leveling. I need you to be aware of that. That instead of taking only one reading at the crosshair, which is the intersection of the horizontal and vertical, which we call it the crosshair, they try to get the benefit of the stadia hairs, which is the top and bottom hair, but the process is still the same. Okay. There is another leveling technique or leveling method. We use it also, and I need you to be aware of. It's called reciprocal leveling. Reciprocal leveling. I need you to know that the reciprocal leveling is a differential leveling. And we use reciprocal leveling in the following situation. Let me, as you recall that we said that when you put your instrument between the 2 points, this is point A, okay, assuming this point is the non-elevation, 168 or 169.4. When I put the rod here on top of this point, I will take a reading, which we said that this is backside, with the point of non-elevation. When I take the rod to the second point B, it must be the same rod to eliminate the instrumental error, by the way. I cannot use two rods at the same time. It will be a mistake. The same rod, I take the same rod and put it here, because if this rod has an error, the error will be the same at the two locations. So I will take the same rod and put it here, and I will read what is known as a foresight, FS. But the earth is not flat like this. The earth actually it has some kind of curvature. Okay, so this is the actual earth surface. If we put this instrument between these 2 points at an equal distance, this is X and this is X, 200 feet here, 200 feet here. It depends on your instrument, how accurate or how the magnification, how far can you see, because each instrument has a magnification, 20x, 30x. It depends on the accuracy. It depends on the power of the instrument. But if we keep these two distances are equal, one is called backside distance and one is foresight distance. So this error here and this error here, they will cancel each other, because I'm going to add this error and subtract this error. This is why we put the instrument is halfway between the points in order to eliminate the curvature and refraction. But if you do have a river, waterway, or canal or any kind of waterway, and you have the point A here
and you need to get the elevation of point B here. Can you put the instrument halfway between these 2 points on the... Yes, sometimes we can do that if you rent a boat or something like that. But I have obstruction here. So they came up with what is known as a reciprocal leveling. If you cannot afford to get a boat or some kind of, okay, to support your instrument here. So in this case, they came up with what is known as reciprocal leveling. Reciprocal leveling. Where they are saying that put the instrument here. This is the first setup, about 10 or 15 feet away from point A. And put the rod and take a reading. And take the same rod and put it here and take another reading. After that, you'll take the same instrument and put it here. Setup number 2. And using the same rod, you'll take a reading here and a reading here. So basically, this is what is happening in this illustration that you see in front of you. So basically, this is reciprocal leveling. This is the river or waterway, as you can see here, to illustrate that. So we put, this is a point A and this point B. So this is setup number 1. And I will take 2 readings. And I will take the same instrument and put it here at setup number 2. And take 2 readings. And I will average the back sides and the fore sides. And I do the process as usual. Okay? Very important to do this in a very short time, by the way. Okay? It should be minimum time. Because the effect of the environmental conditions, it might affect the readings. So I will do the reading, setup number 1, and take the instrument and do it. Don't do this in the morning and come in the afternoon, do this. No, it is minimum, okay? It should be noted that the setups should be minimum time. Okay? I do have a problem here. This is a reciprocal leveling where I have 2 readings. I setup number 1, I have reading. Setup number 2, I have 2 readings. This is a benchmark elevation, by the way, which is given. So I will add these 2. This is the sum, and this is the average. So if you add these 2, you will get this number. If you add these 2, you'll get this number, and take the average. And after that, I know the elevation here. So the elevation plus the average of the backside minus this will give you the reading. Okay? Or the elevation of point B. This is called reciprocal leveling. Okay? Another problem here, problem 920. A rod reading at the top of a pipe is given, and the backside is given, and the benchmark elevation is given. The outside diameter of this pipe is given, and the thickness is given. There must be a 2.5 feet minimum cover. What is the flow line elevation of this pipe? You remember the term that I mentioned, it translates into English. So here I have the following scenario. I have a benchmark. And the benchmark, it does have an elevation of 195.35. And I have an instrument, which is a level, and I put the rod on top of the benchmark, and I took a backside, because the backside reading, it is 4.73. Okay? We are going to put a pipe here, water line or sewer line. So they put the rod on top of this pipe, and they took the reading, and the reading is 13.2 feet. Okay? This pipe has a diameter, outside diameter, be careful, of 42 inches. And the wall thickness, the thickness of the wall T is 3 inches. Are you following me? If you are thinking about lunch now, lunch is going to be, do you remember the joke I told you? Lunch is going to be a circular burger or a square burger. Okay, which one is better, by the way, a square burger or a circular burger? As you know, Wendy's, I believe, is the only one to provide square burger. Okay, most of the burgers are circular. Why? Because heat distribution, for you uniform heat distribution. I believe if you go to Wendy's and get this one, I'm not supporting any, by the way. I'm not. This is not a commercial for any business or advertisement. Okay, the corners here may be burned, by the way, of this, because of the heat distribution. And the buns, most of the buns are circular, and when you slice a tomato, also it come almost semicircular, and our mouth is almost semicircular. So this is why most of the burgers are, if not all, except a few, they are circular burger. Obviously, I don't like you to eat either, because I need your eyes to be open this afternoon. Light lunch, normally I ask for less than or equal 200 calories. I don't know if you can get something in the neighborhood of 200 calories, it will be great. Okay, so let's go, forget the burgers right now. Let's go to the pipe. Okay, so, and he's asking, there must be a minimum cover. What is a cover? When we put a pipe like sewer line, water line, gas lines, we need to provide a cover, which is basically how much earth will be on top of it. This we call it cover, to protect this pipe from the traffic, okay, whatever the traffic on this road. So this is called cover, and I'm sure that you get involved in that, either gas line or water line. And each agency, they have a minimum cover. Some of them, they ask for 5 feet, by the way. I was working in a project, and DWR, Department of Water Resources here in California, they ask for 5 feet. And even we put encasement around the pipe to protect it. So the cover is to protect the utility pipe from any failure because of the load. So he's asking, what is the flow line? What is a flow line? If you design any water system or any sewer system or any drainage system, so the pipe, any pipe that you are using, either concrete or corrugated steel metal, CSM. So assuming this is a pipe, okay. So this here, they call it a flow line. Flow line, or we call it invert, by the way, invert. Okay, there is another, pay attention to the word invert or the flow line. This where you design the pipe, because the pipe is running at a certain slope, and you should know, okay, the flow, the Q, and the Q is obviously depends on the slope, okay? Q, if you remember, there is an equation we are going to see. Q is equal V times A, and one equation is called Manning formula, is 1.486 divided by N, RH 2/3, the hydraulic radius 2/3, is square root of S, and you multiply this by the area. S is the slope, by the way, S, the slope of the pipe. So the slope of the pipe, it must be known, okay, and the flow line elevation is going to be, this is where the profile will be. So this is what he meant by the flow line. A flow line, I need you to be aware of this term, because they might flow line or invert, okay, flow line. So this is a leveling problem, okay. You'll find that I know this elevation, so I will add 4.73 will give me the HI. The HI, I will subtract 13.2 will give me the elevation on the top of the pipe. I will subtract the 42 inches, which is the outside diameter, will give me the elevation of the bottom of the pipe. I will add the 3 inches, which is the thickness of the pipe, will give me the flow line elevation. This is one way, it's up to you. And here it is, the 3 inches I added. And be careful, by the way, inches. And this is feet, and this is feet, and this is feet. Units again, units. It's a good problem. Please look at it, and if you disagree with me, please let me know, or if you need any clarification, okay, please let me know also. Problem number 21, okay, is a conceptual question, and I need you to be ready for both calculations and conceptual questions. On the exam, they ask both ways, or they include both types of. He said that if running a line of levels to establish a benchmark, one backside is misread as 5.35 instead of 6.35. And one foresight misread 6.13 instead of 7.13. What is the net effect? And this is a keyword. Any question, by the way, it has keyword or keywords. And always pay attention to the keywords or a keyword in the problem. Okay, because this is going to be the lead to the, so it's asking what is the net effect on the elevation of the benchmark that established. I misread. So we know the elevation of any point is equal to the elevation of the benchmark and the plus the backside, which is a plus side, minus the foresight. This is what we equation, if you remember the equations 1 and 2. So if you take the reading that was misread and what the correct readings, since I'm adding and subtracting, the difference between them, if the difference is constant, so obviously there is no effect at all. Here he told you the effect will be 2 feet too high, or 1 foot too low, or 2 feet too low, or none of the above. Or he can say no effect at all. Here it is, no effect at all. No effect at all. This is obviously there is no effect. The net, so the net result is no effect because I'm dealing with the adding and subtracting. If the difference is the same, so are you following me? So this is a good conceptual question that I needed to be aware of. Cross sections and the grades, here it is, you'll see that. If you look to this figure here, and obviously the reading I will leave it to you because the time I cannot really read every single word here or single statement. So you promise me that you are going to study and study and study, because you have to study, by the way. And normally I ask for the FE minimum 200 hours. So you have to study 200 hours minimum. Okay, books are available in the market, and the moment I finish my book, but I will send you the 9 chapters somehow, the one I promised with, and hopefully that this summer I will have the book ready. Okay, but if you are taking the exam before that, I'm sure that you search and you will get whatever book or books available in the market, and you try to do your best. But you need to sit and study and solve problems. Solve and solve and solve and solve. As I mentioned before, you need to understand the concept. You need to practice. And I practice a million times. And you go to the exam with the strategy, where you pick the easy questions first. Those are the 3 things that, from my point of view, but obviously you are the one who decide. So understand the concept very well and practice a million times. Any kind of problems available, or you get hold of them, you try to solve them, understand them. And after that, when you go to the exam, you have to go with a strategy. And my suggested strategy is pick the easy ones first, and I will pick the long and the lengthy one, or the most difficult one. I will leave it at the end if I have time. If I don't have time, I will pick one answer, but don't leave anything blank. Pick one answer and pray to God. Okay, that may God accept your prayer and they will pray for you. But prayers only is not sufficient, by the way. Don't say that in every problem you are going to pray to God. Okay, I have an engineer, a friend of mine told me that, Dr. Mansour, shall I go and pray for every problem? And I told him, no. Okay, you need to study and you need to study and study and study and practice and do mistakes. And yes, there are some problems on the exam. Probably you will be surprised you never heard about them, or you did not get a chance to understand the subject. Yes, in this case, 1 or 2 problems you can pray to God, yes, but study and pray to God. Okay, so so cross sections and grades. Any road, and I show illustration here, that here is a profile grade, by the way, the PG and the OG, the original ground. Normally we use these abbreviations. So if I have a profile and I have original ground, I might have some kind of fill, some transition, and some, okay, cut. So we have cut and fill. I needed to know the side slopes. I talk about side slopes, vertical and horizontal, and normally for the English we use 2-to-1. For the metric they reverse it. If you look to this problem here, problem 922, let us try to wrap up as much as I can because I have only a few minutes left. And closure, balancing angles. Yeah, what are there? I think we can. Okay, and I have some problems, by the way, at the end of this chapter. It's called additional practice problems. Okay, and I provided the solutions. So try to do your best. Okay. Problem 9.7. Here he gave you, by the way, moisture content. He gave you the shrinkage. We need to understand, and I provide here with solutions. Oh, here it is. I repeated this diagram again for the last problem practice problem 9.7. So the band cubic yard, loose cubic yard, converted cubic yard, they assume that you understand all these things, by the way, because there is no in the NCAAS equations, okay, or or this diagram, the one I'm suggesting. Okay, if you look to problem 922, said that you are given a profile, okay, sheet that beginning at station 1 plus 45 and the elevation. So I have here station 1 plus 45 and the elevation 350. And they said that this is the starting point. I have a grade of negative, so I went down negative 0.3% to station 4 plus 50. And a grade 1 plus, this is a plus 1.35%. So the grade plus, this is positive grade G, as we're going to see this afternoon in the stopping side distance. Like the stock market, anything goes up positive, anything goes down is negative, as all of us know. So plus 1, this is station until station 10 plus 45. And finally, negative 10, very steep grade, negative 10.8% until you hit station 12 plus 50. So I have point A, B, C, and D. So I have a distance and I have a grade. And he's asking, what is the elevation of this station here? So I need to get the elevation here. So the elevation here is given to be 350. So I know the distance from here to here. And the distance, I use the grade. Normally, I prefer to use stations and drop the percent. Here it is. The elevation at any point along the profile can be calculated using the grades. Okay, and distance sketch. Okay, would be helpful. You may use the station and the slope without percent. This is the most commonly one I use, by the way. So I start with the 350. I know the distance from here to here, from A to B, this 1 plus 45 and this 4 plus 50. So 3.05 stations multiplied by 0.3. Here it is 0.3%. And here's minus. Why minus? Because I'm going down. Plus up. Minus 10 point. So I use the stations and the slopes or the grades, sorry, in this case, the grades, I use the grades without the percentage. This is a very good problem, and go over it and let me know if you have any question about that. Sometimes they give you a cross section like this and some reading, and he's asking what is the side slope. This is called side slope, and this is a side slope, the one I talked about. We know the slope is, we have horizontal distance and vertical distance. So please look to that. Plotting your cross sections, we need to know the cross section, positive, negative, and so on. By the way, I kept here, this is one of the reference that we use. It's called Ash to the Green Book. You are going to see it this afternoon, but they are using the old one. They are using the old green book. I will show you both. They have what is known as the maximum grades and maximum grades for rural and urban freeways and for roads, based on the speed, by the way. For example, this is mile per hour. As you can see, 60 mile per hour. The maximum grade here is for level road, rolling, and mountain. There are three types of roads. We're going to see two of them this afternoon. Level and rolling. Mountain, they didn't provide it for you. So when you look to the topography, so the type of terrain is called the type of terrain, TERRAIN. We have level terrain and rolling terrain, and the third one is a mountain or mountains. This is the level that almost like this. Okay, there is up and down, but not too much. Rolling terrain like the county road, like this. You go up and down. This county road you'll find. Mountain, obviously, you have a mountain. Okay, very obvious. And the AASHTO, they look to these three types of terrains, and they decided three types of terrain, and they decide which is going to be the maximum grade, because, and there is a minimum grade, by the way, minimum grade is 0.5 and 0.3. We're going to see that. There is a maximum grade and there is a minimum grade. Maximum grade or grades, this is AASHTO, and there is a minimum grade also. Minimum grade is 0.3% and 0.5%. This in the snow areas, snow, and this is non-snow areas. To ensure the drainage, because you will never find the road like this. Have you ever seen a road like this, or the roof of your house will be like this, or in business? No, because if I build the road like this, zero slope or zero grade, the water will be here. It was raining yesterday, but they provide a minimum. So this is 0.3% as a minimum. It could be plus or minus, this way or this way. In the areas there is no snow, but for the snow areas like northern states, they provide a minimum 0.5. This is a minimum. You cannot go below, because we cannot have a road that it is level like this because of drainage and hydroplanning and all these issues related to drainage, because drainage is very important. So please, this is just for your information. Nobody will ask you about that. Closure, which is the last few minutes, I will talk about the closure. Any traverse, a traverse is a continuous series of lines, they call them courses, and traverses could be either open or closed. What I need you to know, very important, two equations, okay? One equation will give us the latitude, and one is give us the departure. Latitude and departure. What does it mean, a latitude and departure, or latitudes and departures? Any line, it has two components, one in the X and one in the Y. Okay? So if this line AB, so this line has a component along this direction, or the X direction, or the eastern direction, we call it departure. And this one is called latitude. If I know the slope of this line, or if I know the angle, which is could be a bearing or azimuth. So in this case, we are talking about sine and cosine. So here it is. Here are the two equations to determine what is known as the latitude and the departure. Exactly like we did for statics. Do you remember statics? We said that this is the F, and if this is the angle is given with X axis, for example, we said that Fx is equal to F cosine theta, and this is called F sine theta. Or if you give the X axis the angle with respect to Y, this is F and this is theta. So this is F cosine theta, and this is the F sine theta. So basically resolving the force into components. Here we are substituting or resolving this length here AB into the two components. One is called departure and one is called latitude. And we do that, by the way, because the sum of the latitudes and the sum of the departures must add up to 0. Here it is. In any balanced traverse, it must be a balanced traverse. Okay, so when you have a traverse-based series of lines, okay, they are starting here. So I started with A, and this is B, and this is C, and this is D. Okay, traverse series of lines. Theoretically speaking, I'm supposed to go back again. DA is supposed to go back again, but because we are using surveying equipment and we are human and some errors that will come, so it could be A prime here somewhere. So we are not closing. Okay, so it's called error of closure. This here they call it error of closure. So basically, we calculate the latitude and departure for each course because I know this one, this like this, and the latitude departure for this. And they agreed on a sign convention. I will mention it in just a minute. So this is the latitude and this departure for this line. This is the departure for this course, and this is the latitude. They agreed on the following. This is a sign convention that north latitude is positive, south latitude is negative, and for the departure, the east latitude positive and the west latitude east departure, sorry, is negative. So basically, they agreed on the following. Here it is. If this is north and this is south, and this is east and this is west. So if the line is here, or the course is here in the first quadrant, both of them are positive. This positive and this departure is positive. If the line is here, so this is negative and this is positive, negative, positive. If it is here, both of them are negative, negative, negative. And if the line is here, this is negative and this is positive. So I needed to be aware of this sign convention because the sum of the latitudes plus sum of the departures, they must add up to 0. So the latitudes must be 0 and let me book it in. Okay, because this here I go up and here I go down and go down and go up. So this is positive, this is negative, this is negative, and this is positive. This is for the latitude. For the departure, this is positive and this is positive, this is negative and this is negative. So basically the positive and negative should cancel out if the traverse is balanced. If it's not balanced, balance a traverse. If it's not balanced, we do have a process, by the way. So I need you to know what is known as the error of closure. There is one equation here. It's not given but they are assuming that you should know that. This is the table I was telling you, the standard. This is the standard specifications for a traverse. There are 4 methods. I discussed them also just in case. 4 methods for balancing, compass, and transit. Okay, least square, this is very powerful, but we don't use it. Crandall method is very complicated. I have some problems here, okay, about distances and coordinates and the bearings and a lot, latitudes and departures for lines, sine and the cosine. I needed to be aware of that. There is another problem, 926. What is the bearing of the last course? A very good problem. I needed to be aware of that. And after that, I added the practice problems at the end. Please go over them, and I will be glad to help you if you have any question related to the surveying. So the surveying section I'm providing here is basically a very, very, very condensed of my surveying books. I have 4 surveying books. So I gathered or collected what you need based on the NCEES. Based on the NCEES. So I'm trying my best to stick with the NCEES topics and the subtopics and be concise and be to the point. So you have for the surveying, okay, you're supposed to have from 6 to 9 problems, and these are the topics listed by the NCEES, and this is my material that please look at it and let me know if there is any thing that you want me to double check, if there is a possible typo or mistake or an error or something to clarify, I will be glad to do that. This afternoon, we're going to have 1 hour lunch. Unfortunately, I'm going to use almost half of my lunch to come up with 2 problems. If I'm able, if I'm not, I will send them to you later on. But the package for the transportation this afternoon is very healthy package, very healthy. I have 3 transportation books, and believe me, I extracted what I can get from these books. But obviously, I'm providing you all the equations. Transportation 9 to 14 problems. So also a large number of problems in the transportation section, and I'm providing as usual. These are the equations that are provided by the NCEES. And in the future, as I said, that probably I will add page number here, but I will give you the page number and we'll go over these equations. A lot of material, a lot. Okay, and I provide you with a lot of illustrations in order for you to understand the subject, and it will be fun this afternoon. And this is why I appeal to you not to go to the square burger or the circular burger, we said. So try to get something very light, like salad, 200 calories, and I hope that all of you will. Normally, I look for your eyes to be at least 45 degrees, greater than or equal 45 degrees. I don't like your eyes to be less than that. Okay, so enjoy your lunch, and please stay away from the circular burger or the square burger, as I was joking with you guys. Okay, enjoy your lunch, and after 1 hour from now, it's 12 right now, California time, and 1 hour from now, 1 o'clock, I will start the transportation. I will send it to you within 15 minutes or 20 minutes or half an hour at the most. I hope that you have a printer. You can print them. If not, I will go over the material and you can take notes. And it is recorded anyhow, and it will be available to you also, as I announced that we put all the recordings on our website. So you can go to the website and you can no, this is Amazon. Okay, you can go to my website. Here it is. And as I said that, you will be able, here it is. So if you click on this, it will take you directly. So we already loaded for you guys, and we'll keep it as long as we can. And after that, we are going to get ready for it by the end of the summer. So try to do your best and enjoy your lunch. Thank you very much. Let me grab a question, but one of you has a question or a comment or a suggestion. Let me grab it very quick. Oh, okay, sure. After lunch. What about that? Okay, you are very welcome, my friend. Enjoy. Okay. Thank you very much. Bye-bye. Take care of your lunch. Okay, 200 calories. Okay. Thank you.